In this video, we're going to look at the GCSE Maths 9 to 1 Foundation course and focus on number. This is going to be one of 7 videos in the series, and in each video we're going to look at a different section of the course. So in another video we might, for example, look at statistics or algebra. The idea of the videos is to go through the basic topics, show you how to do them, and then move on to some harder exam style questions to ensure that you can get the top marks. Some of these topics you might find easy and straightforward. If so, just wind the video on until you get to something you find more challenging. So let's start off with number and look at types of number. To begin with, we're going to look at integers. Integers are whole numbers. So an example could be 2, or we might have 5, we might have -4, we might have 106. All of these are integers. If we now look at some non-integers, we might, for example, have 2/5. We might have 0.17. We might have -2 and 1/3. All of these are non-integers. Let's go ahead and look at a typical exam style question we might be asked. So in question 3, it says write down the difference between the largest and smallest non-integer in the list. So let's go ahead and identify the non-integers. 1.7, 6.95 and 1/2 are not whole numbers. The largest is 6.95, the smallest is 1/2. So we can do 6.95 and subtract from this 0.5. If it's a calculator question, simply type it into the calculator. Otherwise, we can go ahead and work this out ourselves. 5 minus 0 is 5. 9 minus 5 is 4, 6 minus 0 is 6, so we get 6.45. If you've got a calculator, let's grab the calculator up, simply type it in, 6.95, and we could subtract from that. You can either type in 1/2 as a fraction, or we could type in 0.5. We hit the S to D button just now to take it from a fraction to a decimal, and that gives us 6.45 as expected. Let's now move on and look at square numbers. When we take an integer and multiply it by itself, the answer or the value is a square number. So if we take 1 and we multiply it by itself, we get 1 squared, and 1 squared is 1. If we take 2 and we multiply it by itself, we get 2 squared. 2 squared is 4. If we multiply 3 by itself, 3 times 3, or 3 squared, gives us 9. 1, 4, and 9 are all square numbers. A common error here is when students see 3 squared, they think it's 2 times by 3. All it's telling us to do is take the number 3 and have 2 of them when we're multiplying. So if we look, for example, at 5 to the power of 4, this is telling me to take 4 5s and multiply them. So 5 times by 5 times by 5 times by 5. It's not telling me to do 4 times by 5, which would be 20. So 5 times by 5 is 25, times by 5, 125, times by 5 is 625. So what we've done here is just generated the first 3 square numbers. If I did 4 squared, that would give me 16. 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is going to be 121, we'll put it just here, and 12 squared is 144. Those numbers you should be able to commit to memory, or at least find them very quickly. Lots of the exam style questions will ask you to consider square numbers. So that's what we've got. It's important to recognise if we have negative numbers and we square a negative number, our answer is positive. Later on in the video, we will look at multiplying and dividing with negative numbers. But if we have -2 squared, that would give me 4. I'm just going to show you the quick difference on a calculator. So if we have -2 and we square this, this is going to give us +4. If we typed in -2 squared, this will give us -4. Again, later in the video, we will look at the order of operations. What this is telling me to do on the calculator, or what the calculator is telling itself to do, is square 2 first and then multiply by -1, rather than multiplying, as we've seen before, the -2 by the -2. Again, we will look at this in a later part of the video. So if we looked, for example, at -11 and we wanted -11 squared, then we're going to get 121. So let's look at a typical exam style question involving square numbers. This is question number 10. It says, here is a list of numbers. We got 1, 5, 3, 17, 8, 4, 21, 17, 0.5, 8 and 17. We won't do all of these questions as we'll come back to them once we looked at other topics, but what we will look at now is this one just here. Write down all the square numbers in the list. So if we look at the square numbers, 1 times 1 is 1, so 1 is a square number. 4 is a square number, as that's 2 times 2, and looking across, there are no other square numbers. So write down the square numbers, we would simply write 1 and 4. What we're asked as well is to write down the non-integer. Hopefully now, after the last section, we can go ahead and write down that the non-integer is the 0.5. Okay, let's move on now and look at square roots. If we square a number, we get a value. What we can do is take the square root of that value and it will give us the number that we started with. It's called an inverse process, or if you like, you're reversing it. When we take the square root of a number, we can get a positive and negative. For example, if we're solving an equation and we said that x squared was 25, the answer could be x is equal to plus or minus 5. In this video, we will focus on what we call the principal value, or just the positive answer. So if we just look now on here, 1 times 1, or 1 squared, is 1. The notation we use is the square root. The square root of 1 is 1. This is the number when multiplied by itself that gives us 1. So the square root of 4 is going to be 2, as 2 squared is 4. The square root of 9 is going to give us 3. The square root of 16 is going to give us 4. The square root, for example, of 81 is going to give us 9. 9 squared is 81, so the square root of 81 is 9. On the calculator, the square root button is here. So if I typed in square root of 81, that would give us 9. So that's what we get, and we can type these in. Square root 25 gives us 5. So that is a square root. What we'll now do is look at cube numbers and cube roots. What we saw before is squaring a number was multiplying it by itself. If we have 1 times 1 times 1, this gives us 1 cubed. 1 cubed is 1. Therefore, 1 is a cube number. 2 times by 2 times by 2 is 2 cubed, or 2 to the power 3. A common misconception here is that the answer is 6. It's not telling us to do 3 times 2. It's telling us to take 2 and we need 3 of them multiplied. The answer is 8. If we have 3 cubed, that is 3 times by 3 times by 3, or we could write that as 3 cubed, and that is 27. 3 times by 3 is 9, times by 3 is 27. So that's cubing a number. The next cube number, 4 to the power 3, or 4 cubed, would give us 64. 5 cubed would give us 125. 6 cubed would give us 216. In a calculator, if we wanted to square a number, we could type the square button here. That would give us 25. If I wanted to cube it, we could press now the power button and insert the 3. So 5 cubed is 125. What we're going to do is look at the cube root. The cube root is the inverse of cubing. So, for example, the cube root of 8 is 2. If we cube 2, we get 8. If we take the cube root of 8, we get 2. The cube root of 27 is going to be 3. Again, on the calculator, we can locate that. Shift square root, and that gives us the cube root. The cube root of 27 is 3. We can put this on. Let's go ahead and put in here the cube root of 125, and that gives us 5. While we're here, what we're going to do is just look at some negative numbers. If we have negative 2 cubed, what we're going to have now is negative 8. The reason being is that we'd have negative 2 multiplied by negative 2 multiplied by negative 2. Negative 2 multiplied by negative 2 is positive 4, multiplied by negative 2 would give us negative 8. So the cube root of negative 8 would give us now negative 2. We're looking at exam style question and going across between square numbers and cube numbers. A typical non-calculator question might come up and it might ask you to estimate either a cube root or a square root. So let's look at a typical square root question we might be asked in an exam. It might ask us to find an approximate value for the square root of 59 without a calculator. The way that I would approach this is to consider now square roots we know. We know that the square root of 49 is going to be equal to 7. The square root of 64 is going to give us 8. We can see there's a difference of 10 between 49 and 59 and a difference of 5 between 59 and 64. So we could say that this is approximately equal to, and we have the wavy lines instead of the straight lines, around 7.6 or 7.7. So all I've done is taken known facts from my square roots and estimated it. If we had a calculator, of course, that would be easy. We would get root 59. This gives us what we call an exact value. All we need to do is hit the S to D button and that will give us now 7.68, which is approximately 7.7. It doesn't have to be massively accurate, so as long as you know, or as long as you can show you have some understanding of the size or the magnitude, as we could say, of that number. Let's look at this exam style question. So some of this we should be able to do based on what we've just learned. So let's go ahead and look at the obvious ones. We've already seen that 5 cubed is 5 to the power of 3, or 5 times 5 times 5, that's 125. We've got 0.5 squared. Later in the video we'll look at multiplying decimals, but 1/2 times by 1/2 is 1/4, or 0.25. Square root of 81 is 9. The cube root of the cube of 2, and again it might be written as the cube of 2 or 2 cubed or 2 to the power of 3. 2 times 2 times 2 is 8. We'll look at this one later on with BIDMAS, or the order of operations. Square root of 25 is going to give me 5. 6 squared is 36. And then some of the others we could fill out. So if we wanted, again, you might be comfortable with some of these, but if not, what we could do is look at some of these. So here it says A1 is equal to 2 lots of C2. So here C2 is 3 lots of B2. Well, 3 lots of B2 is 8, so 3 lots of that is 24. 2 lots of C2, well, that's going to be 48. So that's just a typical question that we might get. Again, I'm not going to fill out the whole table because we'll build up these skills as we go. But if you see a table like that, don't panic, fill out what you know, and then just follow the instructions. So this one right here, C1 is 5 lots of 2 plus 1. 2 plus 1 is 3. 5 times by 3 is 15. So C3 is 2 lots of C1, that would be 30. Again, we'll focus a bit on this later in the video. Okay, let's now move on to looking at prime numbers. There are many misconceptions with prime numbers. Before we go any further, it's important to stress that 1 is not a prime number. The definition of a prime number is that it only has 2 factors, itself and 1. So the factors are the whole numbers that go into a number with no remainder. So if we look at the factors of 1, if I take 1, we've only got 1 times 1. That means that there's only one factor for 1, so it's not a prime number. If we take the number 2, 1 times 2, they're the factors of 2. So 1 and 2 are the factors of 2. So it's a prime number. So this one is prime. 2 is prime. If we look at 3, well, the only factors are 1 and 3. That is prime. If we look at 4, we can have 1 times by 4, or we can have 2 multiplied or 2 times by 2. This is not prime as it's got more than 2 factors. We can say from this point on then that the only even prime number is 2. Another misconception is that 9 is a prime number, as students do 2, 3, 5, 7 and 9. Remember that 9 has the factors 1 and 9, and we got 3 times 3, so this has 3 factors. So let's go ahead and write out the first few prime numbers. So even if you don't remember that definition, you should be able to identify prime numbers and also write them down. 2, 3, 5, 7, 11, 13, then we have 17, we have 19, 23, then we'll have 29, 31, and so on and so forth. So this now is a list of the first few prime numbers, and you should get comfortable with them. Okay, let's look at some exam style questions that involve prime numbers. We're asked to find 3 prime numbers that sum to give 23. At this stage, I'm going to introduce 3 words: sum, difference, and product. Sum means add, difference means subtract, product means multiply. So when we're looking for 3 prime numbers that sum to give 23, all I would do is list out my prime numbers in ascending order, which means smallest to largest, and pick them out. So if we go ahead and look at that, let's go ahead and look. So we need 3 that add to give 23. So I'm looking around this area. Clearly I'm going to choose them from 19 back down, because I can't add 3 numbers that will give to 23 if 23 is one of them. So if I went ahead now and I chose 13, that's a good starting point. 13 plus 7, that would give me 20, plus 3 could give me 23. That's not necessarily unique, so there could be other ways of doing it, but 13 plus 7 plus 3 gives me 23. In question 3, we're asked to add the 3rd square number to the 5th prime number to the 2nd smallest cube number. With any question like this, all we're going to do is list out our square, prime, and cube numbers. So if we write square, prime, and cube, we're going to do this systematically. Don't just try and jump and try and locate these numbers, write them down, and then you'll be able to pick at them. So our 1st square number is 1, our 2nd is 4, our 3rd is 9. The 5th prime number, 2, 3, 5, 7, 11. The 2nd smallest cube number, 1 and 8. So if we look at what we've got now, we want from here the 3rd square number, that is 9, the 5th prime number, that is 11, and the 2nd smallest cube number, which is 8. So all we're going to do here is add these together and we'll get 28. So we can see this systematic listing will help us with these questions. Okay, let's look at another one. Fred thinks of a prime number. If he rounds it to the nearest 10, the answer will be 20. If he adds 3 to it, the number will be a multiple of 5. Find the number Fred was thinking about. So again, all we're going to do is our list. So if he rounds it to the nearest 10, it will be 20. So we can start with 11, we could have 13, we could have 17, we could have 19, we could have 23, and possibly 29. So if we look at these now, which of these round now to 20 to the nearest 10? Well, this wouldn't, it would round to 10, this would round to 10, this one would round to 30. So we've got a choice of 17, we've got 19, and we've got 23. If I add 3 to it, it'll be a multiple of 5. A multiple of 5 simply means that number is in the 5 times table. So if I add 3 to this, that gives me 20, and we can see straight away that he was thinking of 17. If I add 3 to this one, it's going to be 22. If I add 3 to this one, it's going to be 26. So the number he was thinking about is the number 17. So you might have found that straightforward, but that nice systematic listing will allow us to answer that question. We're now going to look at reciprocals. The technical definition of a reciprocal is if you multiply a number by its reciprocal, the answer will be 1. An easier way to think about it is often either writing 1 over the number or turning the fraction upside down. So if we look at the first question, we've got here now, write down the reciprocal of each of the following numbers. So 1 over 5, all we would do is turn this upside down, which would give us 5 over 1, which is, of course, 5 whole ones, or 5. Here, what we've got is 6. If we wrote the number 6 is 6 whole ones. So what we could do is simply write that this is going to be 1 over 6. Alternatively, you can simply say, write 1 over that value. The reciprocal of 2 over 3 is going to be 3 over 2. The reciprocal of a over b is going to be b over a. The reciprocal of y is just going to be 1 over y. So if you have an integer, a whole number, simply write 1 over that value. If you have a fraction, simply turn the fraction upside down, or if you like, invert the fraction. So those are reciprocals. What we're now going to look at are factors, or if you like, divisors. A factor is a number that will go into another without a remainder. So a whole number that will go in without a remainder. What we've got here is a question, and it says write down the factors of the following numbers. You can either do this forwards or backwards. So if we take the number 4, the way we could start it is to take 1. What would I need to multiply 1 by to get 4? The answer is 4. So 1 and 4 are factors. I'll now try 2. 2 times anything, well, the answer is 2. As you can see, the next number would, in this case, not exist because we couldn't do 3, because 3 won't go into 4 without a remainder. So the factors of 4 in ascending order, which means from smallest to largest, is now 1, 2 and 4. Ascending is from smallest to largest, descending is from largest to smallest. So let's look at 6. 1 times by 6, 2 times by 3. Of course, the next number we'd choose is 3. That's already in the list, so we found the factors. So here I'm working forwards. You could have worked backwards and said, is there anything I can divide 6 by to get a whole number? Is there anything I can divide 3 by? I prefer to work forward, but it's entirely up to you. So the factors of 6 are 1, 2, 3 and 6. If we now look at the number 5, well, we know that 5 is prime. We only have 1 and 5, so the factors of 5 are 1 and 5. Let's just take that out. We want 1 and 5. So writing them out can help. I've seen lots of different diagrams to do this, such as spiders' legs. I prefer myself to write them out. So we'll do 24. 24 is, let's start here. 24 is a larger number. 1 times by 24, 2 times by 12, 3 times by 8, 4 times by 6. Can't multiply anything by 5 to get 24, any whole numbers. So that's where we stop. A 6 would be our next. So we'd have 1, 2, 3, 4, 6, 8, 12 and 24. So these are the factors of 24 in ascending order. So let's look at a typical exam style question. It says here is a list of numbers 2, 6, 22, 14, 13, 16, 17 and 27. So we're asked to write down from the list. Remember, these questions say from the list. Students often just write down any prime number. So let's go ahead. We'll do all of this, as much as we can do anyway. So let's have a look now at first the prime numbers. Well, we know that 2 is a prime number. We know that 13 is a prime number. we know that 17 is a prime number. Often students think 27 is a prime number. As we can see, it doesn't appear in our list of prime numbers just here. The reason being is we can divide it by 1, 3, 9 and 27. Cube numbers. So let's look at the list. 2, 6, 22, 14, 13, 16, 17, 27. The cube number is 27. 3 times 3 times 3 is 27. 3 cubed is 27, so 27 is a cube number. Square numbers, 2 isn't, 6 isn't, 22 isn't, 14 isn't, 13 isn't, 16 is, because 4 squared, or 4 times 4 is 16, so 16 is a square number. The factors of 24. Well, I've just written the factors of 24 here, so let's see which ones appear. So we've got 2, we've got 6, and from there, looking at any more, 2, 6, that looks to be it. So the factors of 24 from the list, not just the factors of 24 in their entirety, goes from there. Okay, multiples of 11. We'll move on to multiples now, as that's the next topic. When we see the word multiples, we think times tables. Often factors and multiples are confused. Multiples now of 5, for example, if we looked at, well, here we go, first 5 multiples of each number, first 5 multiples of 4, 4, 8, 12, 16 and 20. It's just the 4 times table. If we look at the next one, 5, first 5 multiples of 5, 5, 10, 15, 20 and 25. So multiples are the numbers that go into another number. We've got now factors and numbers that go into another number. Multiples are just the times table. So let's look at some exam style questions involving factors and multiples. Sue thinks of an even number. Complete the table below. So let's start off by looking at odd and even numbers. Odd numbers 1, 3, 5, 7, 9 and so on and so forth. Even numbers 2, 4, 6, 8 and so on and so forth. So if you're unsure on how to start this question, why not just choose an even number? If you're unsure with anything, it's the same with a question that involves algebra. Bob is thinking of a number. It's a positive number. Often if you just think of a positive number, you can look at some of the properties or features of that number. So Sue thinks of an even number. Complete the table below. The number is positive. Well, if we think about it, we could have negative 4. This is a negative even number. So in our table, we could say either true, possibly true, or false. So this is possibly true. So the number could, for example, be positive 4 or negative 4. So this is possibly true. The number is a multiple of 2. Well, all even numbers are a multiple of 2, so that must be true for all even numbers. The number is a square number. Well, as we've seen before, 4 is an even square number, but 9 is an odd square number. So we've also got, and in fact answering that a bit better, 6 is an even number, but it's not square. So the number is a square number. It could possibly be true, but not always true. The number is a factor of 8. Some even numbers are factors of 8, but some aren't. For example, 6 isn't a factor of 8, so that is possibly true. The number is odd. Well, if it's even, it can't be odd, as we've got odd numbers and even numbers. That must be false. The number is a prime number, so we know that 2 is a prime number, but 8 certainly isn't. 2 is the only even prime number, so that's possibly true. The number is divisible by 2. Well, the definition of an even number is that it is divisible by 2, so that is going to be true. One of the factors of a number is odd. So if we look at the factors of any number, 1 is always a factor of a number, so that must be true. I think the wording could be better here. It should say 1 or more of the factors is odd rather than just 1. As we saw now with the just here, we've got 2 odd factors to 24. So the clarity of that isn't brilliant. Okay, let's look at another one. John can buy a cupcake for 80p, or, I think this should be or 5 for £3.10. Find the cheapest way of buying 24 cupcakes. So, these questions are very, very popular because all they want us to do is look at multiples, but they want us to consider different scenarios. So if we look, first way we can do it now is to buy 24 at 80p. So this would generally be a calculator question. So the first scenario is that we buy 24 singles. So 24 times by 80p or £0.8, entirely up to you. So £0.80. If I did this on a calculator, 24 times by 0.8, this will give me in pounds, and that gives me £19.20. So that's one scenario. The second scenario is that he could buy on here, he could buy the 5 for lots of 5. So we'd have 4 times by 5. And then we would add to that now 4 times by the singles. So if we look at this, what we'd have is 4 times £3.10 plus on here, and I'll just put that in brackets, we would have 4 times by the 80p. So what I've done here is simply looked at buying a multiple of 5, which is 20. So 5, 5, 5 and 5 gives me 20, and then 4 single ones. If you've got the confidence, you can type this straight into the calculator. So what we could do is 4 times by 3.10 plus now 4 times by 0.80. That's going to give me now a total of £15.60. So at the moment we can see this is better. Often these questions say at least 24 cupcakes. As there's another way that we could do this. We could simply buy 5 lots of 5. If I did 5 times by 5, I'd have now 5 lots of the £3.10. That would give us a total of 25 cupcakes, which does give us 24, and we could do that on a calculator. 5 lots of that, what's that going to be? £15.50. So we can see that is the cheapest way. So the way of doing it is 5 lots of 5. So do look at all of the possible scenarios to find the cheapest way. So that's the example of multiples in context. Question 15. Fred thinks of a number. The number is a factor of 12 and a multiple of 2 and a square number. What number was Fred thinking of? I think the best way to do this, instead of guessing it, is to look at the factors of 12. We've seen that the factors of 12 are going to be 1, 2, 3, 4, 6 and 12. So these are my factors of 12. It's a multiple of 2. So straight away we can get rid of the odd numbers. We've got now a square number. So 2 isn't square, 4 is square, 6 isn't square, 12 isn't square, so the answer is going to be 4. Clearly you don't need that amount of working, but hopefully you can see that I'm doing that in a very systematic way in terms of listing them out and considering each one in ascending order. Let's look at the next one. Find 2 numbers that multiply to give 60 and add to give 17. With this question as well, there are lots of different approaches. What I would consider is a systematic approach. So if we think about this reasonably, what we could say now is starting off with 10 and 6. That would be a good place to start. 10 and 6. 10 times by 6 is 60, but they add to give 16. If I now think about the next one, what I could do is 12 and 5. 12 times by 5 gives 60, 12 plus 5 is 17. If you were unsure on locating those, you could have started at the beginning with a list. So a list in ascending order, we could have had 0 and 60. 0 and 17. These two add to give 17 but don't multiply to give 60. We could have 1 times 16. Those add but don't multiply. We could have 2 and 15. 3 and 14, 4 and 13, 5 and 12. So we can see now that adding these two numbers would give 17, and hopefully at that point you could see these multiply to give 60. Again, any form of systematic listing or locating something in the region will help you out with that type of question. Okay, let's move on, and we will look now at the product of prime factors. Every number can be written as a product of its prime factors. So let's look at the definition and each term within that. Product means multiply, prime are the prime numbers, and factors are the numbers that go into another. When we're looking to find a product of prime factors of a number, we use a factor tree. So let's go ahead and express each of the following as a product of their prime factors. Before I start, I'm going to write now my factors, or prime numbers down the side of the page. 2, 3, 5, 7, 11, 13, 17, then we'll have 19, 23 and so on. So what I do is start off with the number 8 in my factor tree. Can I divide 8 by the first prime number of 2? Yes, I can. And all I do is circle the 2. 8 divided by 2 gives me 4. Can I divide 4 by 2? Yes, I can. And that gives me 2, and it gives me 2. So what I end up here with is 2, 2 and 2. We get 2 times 2 times 2. So we can say 2 times 2 times 2. Or if we use index notation, we can say 2 to the power 3 or 2 cubed. We will never have 1 in this list, and all we're looking to do is simply keep dividing until we end up with 2 prime numbers at the bottom. So that's all I've done to get that. Let's look at another number. Let's look at the number, we'll go for 42. So can I divide 42 by 2? Yes, I can, and I get 21. Can I divide 21 by 2? No, I can't, so I try and divide it by the next prime number, which is 3. Dividing it by 3 gives me 7. 7 is a prime number, so we come to the end of our list and we can write that 42 is going to be 2 times by 3 times by 7. Right, let's look at 120. There are a couple of different approaches that you could use to do 120. The first way is to do it like this. So if I took 120, I can divide that by 2, and that gives me 60. I can divide that by 2, and that gives me 30. I can divide that by 2, and that is going to give me 15. I can't divide 15 by 2, but I can divide it by 3, and that gives me 5. So we can say as a product of its prime factors, 120 can be written as 2 to the power of 3 times by 3 times by 5. That's one approach. An alternative approach would be spotting factors that you know. So I know that 10 times 12 is 120, and then all we would do is simply split these up into prime factors, which would be 2 and 5. This one right here is going to be 2, then we'll have 6, we'll have 2, and we'll have 3. So we get exactly the same 2 times 2 times 2 times 3 times 5, which gives us 2 to the power 3 times 2 to the power 3 times by 3 times by 5. Different approaches. I know for larger numbers, some students like to split it into obvious factors and then break those down as a product of their prime factors. So that's product of prime factors using a factor tree. Don't just leave it as a factor tree, write these out. Question 6 here is a typical tough exam style question. Using your answer for 120, write down the product to prime factors of each of these. So this now is our product to prime factors for 120. If we look at 240, 240 is going to give us now 2 times by this. 120 goes into 240 exactly 2 times, or we simply need to multiply 120 by 2. So what we get is 2 times by 2 cubed times by 3 times by 5. At this stage, I'm going to briefly introduce index notation and the laws that we use for powers. If we have 2 or 2 to the power of 1, when we multiply, we add the powers. So 2 to the power 1 times by 2 to the power 3 is 2 to the power 4. So we get 2 to the power 4 times by 3 times by 5. In a later video, we will look at the power laws. But if we have a to the power of m multiplied by a to the power of n, we get a to the power of m plus n. So when you're multiplying with the same base, and in this case the base is 2, you add the powers. If you're dividing with the same base, you subtract the powers. So we get a to the power of m minus n. So later on we'll look more at those, but that's 240. If we look at 120 squared, what this is telling me to do is 2 to the power of 3 times by 3 times by 5 squared. Two different approaches that we could look to do this. I could simply write squared here, or I could write another bracket like so. So we've got 2 to the power of 3 multiplied by 2 to the power of 3, so that gives me 2 to the power of 6. 3 to the power of 1 multiplied by 3 to the power 1, remember that's just a 1, is 3 to the power 2 or 3 squared. Multiplied by 5 to the power 1 multiplied by 5 to the power 1, which is 5 to the power of 2. So all we're doing is simply doubling up the powers. If you wanted, you could simply double the powers from the start. 1200, well this is simply going to be 10 times by 120. Product of prime factors for 10 is going to give us 2 multiplied by 5. And then we would multiply that by our answer of 2 to the power 3 times by 3 times by 5, which gives us 2 to the power 4 times by 3 times by 5 to the power of 2. So a much more challenging question. So that is product of prime factors. So quite challenging little skill, but if you have a calculator, you can use a calculator. So let's go ahead and look at the product of prime factors on a calculator. So if I take 120, all I'm going to do is press equals. I hit shift and then the button here that says fact above it, and it will do it for me. So 2 to the power 3 times by 3 times by 5, which we've just seen. If we had, for example, now 27, we hit enter. This will give us 3 to the power of 3, and we can do it like so. We did 42, hit 42, enter, shift factorial, 2 times 3 times 7. That is there if you want it. And hopefully, if we look at 1200, that's the one we've just done, and that gives us exactly what we expected just there. But again, often this is on a non-calculator paper. Let's now move on, and we're going to look at the highest common factor. If we have two numbers or more, we can find the highest common factor of those two numbers. The highest common factor of two or more numbers is the largest number that goes into both of them. So let's start off with a nice straightforward example. If we have now the number 6 and the number 8, and we want to find the highest common factor of 6 and 8, the first thing we could look to do is list out the factors. We've seen previously that the factors of 6 can be written as 1, 2, 3 and 6. The factors of 8, so the whole numbers that go into 8 without a remainder, are 1, 2, 4 and 8. So we can see now that the largest number in both lists is 2. 2 is the highest common factor of 6 and 8. Often people get highest common factor and lowest common multiple mixed up. We're going to look at lowest common multiple or least common multiple shortly, but the highest common factor, largest number that goes into two or more numbers. So let's have a look at, for example, 12 and 16. If we look at the factors of 12, the factors of 12 are going to be 1, 2, 3, 4, 6 and 12. If we now think about 16, we could list the factors out, or we could simply work backwards with 12 and ask ourselves, does 12 go into 16 with no remainder? The answer is no. Does 6 go into 16 with no remainder? No. Does 4 go into 16 with no remainder? Yes, it does. So the highest common factor of 12 and 16 is 4. So that's one way you can do it. We could look at expressing a number as a product of its prime factors. This method is probably slightly beyond the scope of this course, but you could use product of prime factors. So let's look at the method of using product of prime factors. If we express 12 as a product of its prime factors, we could write that 12 was going to be 2 times 2 times 3, or 2 squared times by 3. So as a product of its prime factors, we've got 2 squared times by 3. As a product of its prime factors, 16 could be written as 2 to the power of 4. If we're finding the highest common factor using the product of prime factors method, what we need to do is look at these two lists. We take the number that appears in both lists to its lowest power. So we can see that only 2 appears in both lists. 3 doesn't appear in 16, and we take 2 to the lowest power of the two lists, and that's going to be 2 squared, which is going to give me 4. So that's another way in which you can find the highest common factor of two numbers. Okay, next one. This here is an exam style question. Often you'll just be asked to find the highest common factor and the lowest common multiple. It says write down a pair of numbers that have a highest common factor of 4. Listing can help with this. Often I just think about now the number 4. The reason I think of a number 4 is that we know that the highest factor, or the largest factor, is going to be 4. We would have 1, 2 and 4. Then all I need to do now is choose another number that 4 will go into. So for example, if I chose 8, we've got 1, 2, 4 and 8. So write down a pair of numbers with the highest common factor of 4. That is an example there. So all I was doing is looking at multiples of 4. A few different approaches on that, but that's one way. So highest common factor. Let's now move on to the lowest common multiple, or the least common multiple. Lowest common multiple and highest common factor are often mixed up, and a lot of the time students say that the lowest common multiple of two numbers is 1. That is generally not correct. What we're going to do here is look at finding the lowest common multiple a couple of different ways. The easiest way is to simply list out the multiples of each number, or if you like, the times tables for each number. So if we go back to 6 and 8, for example, if we take 6, what we're going to have now are the multiples of 6. 6, 12, 18, 24, 30, and so on and so forth. If we look now at 8, we can say that the multiples of 8 are 8, 16, 24, 32, and so on and so forth. The lowest common multiple is the first number that both 6 and 8 go into. We can see in that list that that number is going to be 24. It's the first number that appears in both lists. So lowest common multiple isn't 1, it's the first number these two both go into. So that's what we have. 24 is the lowest common multiple. Sometimes if you multiply the numbers, you will get the lowest common multiple. In this case, though, if we'd multiplied 6 and 8, we would have got 48. So do be careful. So that's one way of doing it, and probably the easiest way. An alternative approach is to use the product of prime factors. Again, this technique is slightly more challenging, but may be asked at the top end of this course. So if we look at the product of prime factors for 6, we know that 6 can be written as 2 times by 3. If we look at 8, we know that 8 can be written as 2 times 2 times 2, or 2 to the power of 3. What we do for the lowest common multiple is take every number that appears in either list and take it to the highest power. So here we would have now a 2 and a 3, because we've got 2 and we've got 3. All we would do now is take the highest power. So the highest power, this is 1, remember, and this is 1. So we'd have 2 to the power of 3 times 3 to the power of 1, which is going to give us 8 times by 3, which of course gives us 24. So that's the more advanced approach. And certainly with bigger numbers, if you've already got them as a product of their prime factors, that method can help. So this is a typical basic exam style question looking at finding the highest common factor and the lowest common multiple of two numbers. So find the HCF, highest common factor, and LCM, lowest or least common multiple of 8 and 12. So if I just go ahead and write 12 here, we should know now that the multiples of 12 are going to be 12, 24, 36, and so on and so forth. So straight away we can see now that the lowest common multiple of 8 and 12 is going to be 24. So LCM is going to be 24. The only reason I've gone for that one first is because we've got them listed out. If we look at the HCF, the highest common factor of 8 and 12, well, we've got now the factors of 8. The factors of 8 are 1, 2, 4, and 8. And then with 12, if you wanted to list them out, you could do 1, 2, 3, 4, 6, and 12. Alternatively, you can just work with this list and see if these go in. So from our two lists, we can see now that the largest number that goes into both is 4. Highest common factor of 8 and 12 is 4. Question number 5. This is a typical wordy question involving either the highest common factor, or in this case, the lowest common multiple. Fred is having a party. He needs a bun for every burger on the barbecue. Buns are sold in packs of 8 and burgers are sold in packs of 6. What is the minimum number of packs he must buy of each to ensure every burger has a bun? This is just a lowest common multiple problem. So we can see now here that we've already done the work for this. So if I just take these just here, let's just highlight these. What we've got now are the multiples of 6 and the multiples of 8. We've already established that the lowest common multiple of 6 and 8 is 24. So we can see now, and I'll just put here that these are going to be, and we'll write this on, these are going to be the buns. The buns are sold in packs of 8, so these would be the buns, and burgers are sold in packs of 6. So if we were buying burgers, we could either buy 6, 12, 18, 24, 30, and so on and so forth. If we were buying buns, we could either buy 8, 16, 24, 32, and so on and so forth. So if we wanted now the lowest common multiple we've established already is 24. A common error here is that students write 24. We can see if it's 24, we would need a total of 4 packs of burgers. And if we needed 24 buns, we would need 3 packs of buns. So all we do, find the lowest common multiple and then just make sure we're answering the question. So 4 burgers and 3 buns. Let's now move on and look at rounding. I think we're going to do most of the rounding here, starting with decimal places, and then we'll move on to significant figures. Often you'll be asked as well to round to the nearest integer. We've looked at rounding, or we've looked at integers before, and we'll bring that in as we go. So what I'm going to do is start looking at rounding numbers to decimal places. We'll do 1 decimal place and 2 decimal places. If you can do 1 decimal place and 2 decimal places, you can do 3 decimal places. So what we've got here, and we'll start down the bottom, we've got the number 2.3676. It Doesn't matter how many digits afterwards we get, if we're rounding to one decimal place, we're focusing on the number just here. So this is one decimal place, or if you like, to the nearest 1/10. My choices are either going to be 2.3, so I'll just write that in here, 2.3 or 2.4. When we round into one decimal place, we look at the number to the right of the 3. If this number is 5 or more, we round up. If it's 4 or less, we round down. We can see now that 6 is going to be greater than 5, therefore we would round up to 2.4. If this number was, for example, 2.34 and so on and so forth, we would round down to 2.3. What we certainly would never do is round down to 2.2. It's never going to be less than 2.3. So when we're talking about rounding down, we're down now to the 0.3 rather than 0.2. So let's now look at, let's go for another one. Let's go for this 12.1263. So to one decimal place, we've either got 12.1 or we've got 12.2. Let's just put a little bubble around this so we can see it a lot easier. So to one decimal place, this is the number we're focusing on. And all we need to do is look to the right and establish whether we're going to round up or round down. 2 is going to be 4 or less, therefore we would round down and we would have 12.1 to one decimal place. This number would have to be 5 or more to round up. We can ignore these numbers here when we're rounding to one decimal place. Let's do 5.654. So we're going to round this to one decimal place. This is the number we're focusing on. So we look to the right. If this is 5 or more, we round up. If it's 4 or less, we round down. So my choice is to one decimal place at 5.6 or 5.7. We can see now that this number after the 6 is a 5, therefore we would round up, and that would give us 5.7, correct to one decimal place. Let's do a slightly more challenging one. Let's round 7.96 to one decimal place. So this is the number we're focusing on, the 9. If we look here, 6 is greater than 5. So what this is going to do is round it up. My choices to one decimal place will be 7.9, or we would have 8.0. We know the 6 will round it up, therefore what we're going to have now is 8.0. So just be careful with those, and remember it's one decimal place, so your answer is going to have these 2 digits just here, 8.0. Clearly, if this one here, we would have the 3 digits, but we've only got 1 digit after that decimal point. So that's rounding to one decimal place. Let's now look at rounding to 2 decimal places. So if we take this number again, 2.3676, this time the second decimal place here now is to the nearest 1/100th or 1/100th. So my choices are going to be 2.36 or we'll have 2.37. So 2.37. We do exactly the same. We look at the number to the right of our value of 6 here. We say if it's 5 or more, we round up. If it's 4 or less, we round down. So we can see here that this value is going to round it up. So to 2 decimal places, this is 2.37. If we take the number 5.143 and we wanted to round this to 2 decimal places, we focus on the number here. My choices are 5.14, or we could have 5.15. We can see on here that the number after the 4 is a 3, so we would round down and it becomes 5.14. So that is rounding to 1 and 2 decimal places. Let's now go ahead and look at the next section, which is rounding to significant figures. When we read a number from left to right, the first number that isn't a 0 is the first significant figure. So if we look now at the number 364.1. This number is the first significant figure, this number is the second significant figure, this is the third, and this is the fourth. So this is the first, this is the second, this is the third, and this is the fourth. If I wanted to round this to one significant figure, this is the number that is likely to change. Or if you like, in this particular number, we're rounding to the nearest 100. The first significant figure, if you had a hundreds, tens, units chart or a place value chart, is hundreds. The second number is tens. The third number is units. So if I was rounding this to one significant figure, I'm rounding it to the nearest 100. So my choices are 300 or 400. All we do is look again to the right. If that number is 5 or more, we round up. If it's 4 or less, we round down. So to one significant figure, this is going to be 400 as we've got the 6. If you look at it logically, 364 to the nearest 100 is 400. If we were doing this now to two significant figures, well, the second significant figure now are, in this number, tens. So we're rounding this to the nearest 10, 360 or 370. So if I wanted this number to two significant figures, 360 or 370, we look just here. This now gives us a 4. 4 is less than 5, so to two significant figures, or the nearest 10, this would be 360. I think that's an easier way to think about it. If you understand the size or magnitude of a number, just think, what are we rounding this to? So, nice and logical, nice and straightforward. We could actually do this to three significant figures. My choices now to three significant figures are 364 or 365, as we're rounding to the nearest unit or nearest integer. So the nearest whole number, 364 or 365. We look at this value just here, that's 1. So to three significant figures, we've got 364. Do be careful with significant figures because we might, for example, have 0.4672. This here is not significant. The first significant figure is the 4. The second one is the 6. The third one is the 7. And the fourth one is the 2. We might have others. We might have, for example, 3, 9, and so on and so forth. First significant figure, second significant figure, third significant figure, fourth, and so on and so forth. The reason this is when we read that number from left to right, the first significant figure is the first one with a value. So it's a non-zero. So if we look at this now, the first significant figure, or if you like, we're rounding this to the nearest 1/10 or 0.1. So my choices would be 0.4 or 0.5. As with rounding decimal places, and as we've just seen with significant figures, we look to the number now to the right. We know now that 6 is 5 or more, so we would round up to 0.5. To two significant figures, my choices now are going to be 0.46 or 0.47. So we're considering now this part here. So this is 1/100th or 0.01. So we're rounding this now to the second decimal place, essentially. We can see that the number after the 6 is greater than 5, therefore it would round to 0.47, correct to two significant figures. Three significant figures, I can either have 0.467 or I could have 0.468. 46, let's put 468 rather than 486, 468. I look just here after the 7. The 7 is followed by a 2. 2 is less than 5, so to three significant figures, it'd be 0.467. So that's rounding now to significant figures and decimal places. Okay, let's move on. And we will now look at estimations and approximations. With estimations and approximations, all we're doing is looking for a ballpark figure to a calculation. With this particular course, the general method is to round each number to one significant figure, write it down, and then carry out the calculation. The idea of estimations and approximations, for example, could be when we're in a supermarket and we buy 49 bars of chocolate for 95p. All we would look to do is round each of those to get an approximate value. So 49 could be 50, 95p could be 100p or a pound. We would carry out that calculation to get that quick ballpark figure. Although we generally do round to one significant figure, as long as you're showing what you've done in terms of a rounding, you won't necessarily be penalised. But if in doubt, one significant figure. So let's look at this one here. We're asked to estimate 9.7 times 4.8. So what we've got is 9.7 times by 4.8. Clearly this would be a non-calculator question. So to one significant figure, 9.7, my choices are 9 or 10. We would take 10 because the 7 will round it up. To one significant figure, we've got 4.8, that would either be 4 or 5, so we choose 5. 5 times 10 or 10 times 5 is going to be 50. So this is an estimate for this calculation. It's not brilliant, but I've shown exactly what I'm doing in terms of a rounding, and we've just come up with a rough approximation to that answer. If we look at the next one, we've got 103.2 times by 19.7. 103.2 to one significant figure is just going to be 100. Remember, we're rounding to the nearest 100. 19.7 to one significant figure. Our choices are either going to be 10 or 20. We're rounding to the nearest 10. And this is where we come into, for example, if it's 14.9 to one significant figure, that would be 10. So you might actually want to say, well, it would be 15, and you wouldn't be penalised in an exam for doing that. So all I'm going to do is put that this is 20, and we can do 100 times by 20, which is going to give us 2,000. So that is an approximation. As I say, with some of these, I really do struggle with the calculations, but as long as you're showing some form of working in here where you've rounded to find an approximate value, you will get credited for that. An example of where I struggle to accept this as a method sometimes, for example, if we did 149, close to the example I've just given, times by 14.9, if we rounded each of these to one significant figure, this would be 100, and this is going to be 10. I would personally do 150 times by 15 because that's going to give a lot better approximation. But as stated, as long as you're showing some technique, then you will get credited for that. Right, let's look at this one before we move on, because this one is fraught with danger and is often done wrong. So 108, so we've got 108 plus 9.8 divided by 0.49. So if I just go ahead and round each of these values to one significant figure, that would be 100, one significant figure, that's going to be 10, one significant figure, this is going to be 0.5. So what we have is 110 divided by 0.5. Often students write that the answer to this is 55. It isn't. We're dividing by a half. Dividing by 1/2 is the same as multiplying by 2. We will look at dividing fractions and decimals later on in this video. But all we have here now is how many halves go into 110. As much as mathematicians dislike using pizzas, if I had 110 pizzas, how many halves could I get out of my 110 pizzas? The answer is 220, because for every one pizza, I can have 2 halves. So how many halves go into 110? The answer is 220. So that is an approximation. Let's look at a wordy question, a typical exam question if you're asked to estimate. Helen works in a factory. She earns £5.98 an hour and works for 39 hours a week. Explain why her wages cannot be more than £240 a week. All we would look to do is round this. So I would simply write rounding. So rounding, what we're going to have, 5.98 will go to 6. 39 will go to 40. 6 times by 40 is going to give us £240. What we've done here is rounded. So rounded each value up. So each value up to the max, up to max. Therefore, it could never be more than 240. So I'd say these max values, using an approximation, would be 240. So some explanation along those lines would be perfectly fine. Again, non-calculator question, nice and straightforward. Any explanation would do. Okay, what we're now going to do is look at intervals and bounds and error intervals. This is one of the more challenging topics, so what we'll do is kind of break it down and look at it nice and slowly. We'll start here. I think this is a good place to start. A table is 120 centimetres correct, or to the nearest 10 centimetres. We're asked to write an inequality to represent the lengths the table could take. So this table has been measured and it's 120 centimetres correct to the nearest 10 centimetres. What that means is that it can take a range of different values. So if we think of all of the numbers that would round to 120 centimetres to the nearest 10 centimetres, if we look at them, if we have 110, 111, 112, 113, 114, 115, 116, and so on and so forth, just writing these down. All of these values here, and of course if we went up, and I'll just write these just here, dot, 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 we've got 1, 2, 3, for example, 1, 2, 4, and 1, 2, 5. If we take now all of these values just here, to the nearest 10, these are going to round down to 110 centimetres. All of the values from 115 right the way up to 124, if we rounded these now to the nearest 10 centimetres, would give us 120. What we need to consider though, between 124 and 125, all of those values would. As soon as we get to 125, that would round up to 130. So what we could do is write that the length now is going to be equal to or greater than 115 centimetres, yet in turn less than 125 centimetres. So we don't include the 125 because 125 would round up to 130. So what we've got here is an error interval. We've got what we could call the lower bound, the minimum value it could be, and then the upper bound, which is the maximum value it could be. So all we've done is simply gone ahead and written that the length is going to be equal to or greater than 115, yet in turn less than 125. Let's look at another example. Let's say a number was rounded correct to one decimal place, so 1 dp, and it gave us 6.5. If we wanted to write an inequality to represent all of the values that this number could take, all we would do is simply consider one decimal place. Now, one decimal place is going to give us 0.1. One technique that we could do is to halve this. So this would be 0.05. So all I would do at this stage is simply draw a line. So what we can do is subtract this amount, 0.05, or we could add this amount, which is 0.05. So what I could say now is that the lower bound, or the minimum value, is going to be 6.5 minus the 0.05, which is 6.45. If I add this on, that's going to give me 6.55. So we could say that that number would be equal to or greater than 6.45, yet in turn less than 6.55. So that's an inequality to represent all of the numbers that it could be. If we look at this, we could have used exactly the same method. So what we had was 120 centimetres. We know that we've got now 10 centimetres to play with. That means that we would simply take 5 off or add 5 on. All I'm doing is halving this interval and adding and subtracting. So 5 centimetres off would give me 115. 5 centimetres on would give me 125. So everything in this particular interval up to this point will round to 120. So we could simply write now again that the length is going to be equal to or greater than 115, yet in turn less and strictly less than 125. Okay, let's move on. Fractions to decimals. So what we're going to do is look now at different ways of converting fractions to decimals, decimals to fractions, percentages, and so on and so forth. Before we go any further, it's important to understand that if you've got a calculator, you're going to use it. So let's now look at fractions to decimals. So on the calculator, I can press the fraction button. If I had 2/5, I could type that in and it would give me 2/5. If I hit my button here, S to D, it will convert that to a decimal. So in an exam, if you've got a calculator, use it. In the same way, and we'll just look at this now, we could type in a mixed number. Shift and we can press the fraction button. This gives us a mixed number. A mixed number has an integer part, in this case 2, and then a fraction as well. So if we did 2 and 1/8, for example, we could hit enter. I could press S to D and that would give me 2.125. So I'm converting 17/8 to 2.125. If you hit shift, it will give you the mixed number as well when you're switching. So important that we know that. Let's look at some obvious fractions to decimals. For example, hopefully we should know that 1/2 is going to be equal to 0.5. 1/10 is going to be equal to 0.1. They're the obvious ones that we've learned. What we'll do though is look at a method we could use if we were unsure to find what we call terminating and recurring decimals. So all we're going to do at this stage is find a decimal value from a fraction, and let's grab this up, and we will do, for example, let's go ahead and do 3/5. Let's say we didn't know how to find 3/5 as a decimal. We can simply go ahead and divide. So all I would say now is 5 on the outside. We will have 3.000. So what we're going to do is use short division. Does 5 go into 3? The answer is no. I then think, does 5 go into 30? Yes, it does. It goes in exactly 6 times. So we finished at that point because it's gone in with no remainder. So 3/5 as a decimal can be written as 0.6. We'll look at this one shortly, but if we wanted to, for example, do 5/8, and we didn't know this, and we needed to use division. So we've got 8, we've got 5, and then we'll put some zeros. Does 8 go into 5? The answer is no. Does it go into 50? Well, 6 times 8 is 48, so it will go in 6 times with a remainder of 2. Does 8 go into 20? Well, 8, 16, it goes in twice, and we have a remainder of 4. Does 8 go into 40? It goes in exactly 5 times, so we end up with 0.625. So that is how to find a decimal from a fraction without a calculator. We call these terminating decimals, as they're not continuing. We can see it stops at this point when 8 goes into 40 exactly 5 times. We might not be that lucky, and we might get a recurring decimal. So we might be asked, for example, to write 4/9 as a recurring decimal. We would do exactly the same. So 9 on the outside, we would have 4 on the inside, write a load of zeros. Does 9 go into 4? The answer is no, it doesn't. 0 goes there. Does 9 go into 40? Well, it's going to go in 4 times. That will give us 36, and we'll have a remainder of 4. Does 9 go into 40? Yes, it does. It goes in 4 times with a remainder of 4. Does 9 go into 40? Yes, it does. It goes in 4 times with a remainder of 4. So what we can see is that this pattern is going to repeat. So what we can say then is that this is going to give us 0.4444, and this will keep going, or recurring. This will never end. We can write this as 0.4 recurring. So all we do is put a little dot above it. Hopefully the calculator will show this. 4 divided by 9, that gives me now 4/9, and then we have 0.4. On your example, it might give you the little dot above it, but that will just keep going. 0.4 recurring. Hopefully your example, your calculator that you have to hand, will have a little dot above. So just say 0.4 and then a little dot above it. That means 0.44444, and this will just keep going. So that is how to turn a fraction into a recurring decimal. Here we've got a couple of exam style questions. Given that 1/4 is equal to 0.25, write down the value of 1/8 and 5/8 of a decimal as a decimal. So if we've got 1/4, 1/4 gives us 0.25. If we look at the relationship between a quarter and an eighth is a half of a quarter. So 1/8 is just going to be half of this. Half of 25 is 12.5. So half of 0.25 is 0.125. All we would do here to find 5/8 is simply multiply this answer by 8, this one just here, and this would give us 0.625. So nice and logical, nice and straightforward. Later on we will look at more work with fractions, but understanding the relationship between a quarter and an eighth is quite important. Just here, without a calculator, show that 5/8 is less than 0.65. Well, I've already done that using short division, and we can see now, and we can write this on here, 0.65 is quite clearly greater than this. And we could just simply say, writing it out, 0.625 is less than 0.65. Okay, let's move on and look at decimals to fractions. Again, if this is a calculator paper, decimals to fractions. So if I wanted to type in 0.2, and let's put 0.2, could have just put 0.2, 0.2 will give us 1/5. So type it in, press the equals button, and you can convert from the fraction to the decimal like so. Often these will have to be written in their simplest form. So there are obvious ones that you should be comfortable with. So for example, if we have 0.1, this is going to be 1/10. If you want to look at this as in terms of the place value, we've got 0 units and 1/10. If we've got now 0.01, this is going to be 1/100th. So again, in a hundreds, tens unit chart or place value chart, that gives us 0.01, which is 1/100th. Sometimes we will be expected to cancel down. So if we have, for example, 0.24, we could write this now as 24/100. We would look to simplify this. This is perfectly fine, but generally speaking, we would look to simplify. If you can spot common factors, so they're numbers that go into both 24 and 100, you can divide the numerator, the top, and the denominator, which is the bottom, by that amount. So for example, I know that I could divide 24 by 4, which would give me 6. And I know that I could divide 100 by 4, which would give me 25. So in its simplest form, it would be 6 over 25. If you're unsure, you could look to half it and half it again. If you can't spot a factor, you could divide it by prime numbers. It's entirely up to you. But if we go ahead and type this into the calculator, 0.24, this will give us now 6 over 25. If we look at a few more, let's say we've got, for example, 0.107, we could write this now as 107 over 1000. So 107 over 1000, 107 is going to be prime, we can just check. So 107 over 100 over 1000, and that's going to give us exactly what it is, as it won't simplify. And we can see now that's 0.107. So all we're doing is simply writing now over a tenth, or over 10, over 100, or over 1000, and so on and so forth, and cancelling down. So non-calculator, cancel down. We'll do another one, we'll do 0.35. So we can write this now as 35 over 100. I can divide both of these by 5. If I divide both by 5, 35 divided by 5 is going to give 7. We've got 100 divided by 5, which gives 20. So again, if we type this in, we've got 0.35. This is 0.35, 0.35, 7 over 20. So that's decimals to fractions. Okay, let's move on now and look at percentages to decimals. So let's start off by looking at what a percentage is. Percent means out of 100. So for example, if we had 35%, this means 35 out of 100. If you wanted to write it as a fraction, we could write it as 35 over 100. What we're going to do is look at writing 35% as a decimal. If you've got a calculator, you can just type it in. So if you want to type it in, you can put 35 out of 100, and this will do it for you. So 35 out of 100, and that gives now 0.35. Alternatively, you can simply divide the percentage by 100. So if we look now, for example, at 43%, we could write this now as 43. So 43.0, if you're dividing by 100, you can either think about moving the number across the decimal point, or you can think about it getting 100 times smaller. So if we made it 10 times smaller, if we made it 100 times smaller, the decimal point would go just here, and we'd have 0.43. If we had, for example, 43.5% as a decimal, this would be 0.435. Major stumbling blocks for students is that they think that writing 5% is going to be 0.5. 5% is 0.05. Think about this. This is 5 100ths. 5 100ths, as we've seen in a previous section, will give us 0.05. 0.5 is a half, which is 50%. So if you convert in percentages to decimals, simply divide by 100, whichever method you want to use. So on a calculator, type it in, otherwise divide the number by 100. Let's now look at fractions to percentages. We're going to look at it first non-calculator, and secondly with a calculator. If we go back to the definition of a percentage is out of 100. So let's look at some non-calculator examples. Let's say we scored 10%. So hopefully we should recognise that the fractional equivalent to this would be 1 over 10. So let's look at this now as a fraction into a percentage. So if we take now 1 over 10, I can go ahead and convert this by scaling the fraction up. Whatever I do to the top of a fraction, I need to do to the bottom of a fraction. What we want is this number out of 100. So I know that 10 is a factor, so 10 goes into 100. So all I'd need to do is multiply this by 10. If I multiply the denominator, so the bottom by 10, I need to do the same to the numerator. 1 times 10 is 10, 10 times 10 is 100, 10 out of 100 is going to give me 10%. So what I've done here is simply converted 1/10 into a percentage. So when we have now a factor or something we could easily manipulate to give us a factor of 100, we can do it without a calculator. So for example, if I had the fraction, let's say 3/20, and I wanted to convert this into a percentage, we would simply multiply the numerator and the denominator of this fraction by 5. 5 times 20 is 100, so 3 times 5, this is going to give us now 15 over 100. 15 over 100 is 15%. So nice and straightforward. If we had, for example, something out of, let's say we had 10 out of 40, there are a few different ways that you could do this. You could half it. We could write this now as 5 out of 20. Or we could divide these by, on here, if we divided this by 10, we would get 1 over 4. If we divided it by divided by 4, what we would end up with is a non-integer in the numerator, but we would get 2.5 over 10. So we can see if it's over 40, there are different ways that we could do it. With this one, we would just multiply the numerator and the denominator by 5, so that would give us 25 over 100, or 25%. This one, we would multiply the numerator and the denominator by 25, so that would be 25 over 100, which is 25%. With this one, we'd multiply the numerator and the denominator by 10, which would be 25 over 100. So just look and getting that as a factor of 100 and then multiplying up. Okay, so that's without a calculator. If you've got a calculator, you can simply multiply the fraction by 100. So let's say we had now a test and someone scored 3 out of 17 in a test, and you wanted to write this now as a percentage. If we multiply it by 100, this is going to give us 17.647, so 17.6% correct to 1 decimal place. Alternatively, what we could have done is just typed in 3 over 17, and that would have given us the decimal answer, and you can multiply that by 100 in your head if you want. So that's converting a fraction to a decimal. To take a decimal to a percentage, we just multiply by 100. So as we can see, multiplying this by 100 is going to give us now exactly the same, 17.6. So fractions to percentages, non-calculator, simply look to see if the denominator is a factor of 100 and multiply the numerator and denominator accordingly. With a calculator, just multiply your answer by 100. Okay, we're now going to go on and look at simplifying fractions. By this stage of the video, we've done a bit of this already. What we would do if we wanted to simplify a fraction is start off by looking at common factors. So for example, if I had 4 over 10 and I wanted to write this in its simplest form, well, we know that 4 doesn't go into 10 without a remainder. That's my first question. If it was 4 over 8, 4 goes into 8 twice, so we could just write it as 1 over 2. But I know that I can divide both of these by 2. 2 is common to both 4 and 10. If I divide this one by 2, I get 2. If I divide this one by 2, I get 5. So in its simplest form, 2 over 5. If you're unsure on the calculator and you wanted to check this in your own time, 4 over 10 will simplify to 2 over 5. The calculator will always simplify it for you. Let's say we had 7 over 21. Does 7 go into 21 without a remainder? 7, 14, 21. Yes, it does. It goes in 3 times. So we could simply do 1 over 3 because we can divide both of those by 7. What I've done here is put the prime numbers, or the first few prime numbers, in ascending order. Sometimes if you can't spot common factors, try dividing it by 2. If it doesn't divide by 2, try and divide it by 3. If it doesn't divide by 3, try by 5, try by 7, and 13, and so on and so forth. So for example, if we had, let's say we've got, let's go for 15 over 35. We know we can't divide both of these by 2 and get a whole number. We can't divide both of these by 3 and get a whole number, but we can divide both by 5. Dividing 15 by 5 gives me 3. Dividing 35 by 5 gives me 7. So 3 over 7. Okay, this is a typical exam style question on a non-calculator paper. If you get it on a calculator paper, simply type each one into the calculator, hit the answer button, and it will help you out. So it says, which of the following fractions have the same value? So what we're going to do is look at each in turn. All I'm going to do here is write these as equivalent fractions, or if you like, simplify them and compare them. So if we look at 2 over 8, we could simplify 2 over 8 to 1 over 4. We can divide the numerator and the denominator by 2. If I look at the next one, we've got 5 and 15. 5 goes into 15 exactly 3 times, so we could simplify this to 1 over 3. If we look at this one, we can simplify it down. 7 goes into 28 exactly 4 times, so this one would be 1/4. What we've got here is 3 over 12. 3 goes into 12 exactly 4 times, so we would have 1 over 4. So what we can see are now that 2 over 8, 7 over 28 and 3 over 12 are what we call equivalent fractions. That means they have the same value. So which of the following fractions have the same value? We would say that it's the 2 over 8, the 7 over 28 and the 3 over 12. Often it will say which of these is the odd one out in terms of its size. So equivalent fractions just here, and the odd one out is the 5 over 15 or 1 over 3. Okay, let's now look at mixed numbers. We just looked at fractions and now it's mixed numbers. An example of a mixed number is 2 and 1/3. With a mixed number, we have an integer part just here and then a non-integer part, so a fraction. So here's a whole number and here's a non-whole number. What we can do on a calculator is type in here, if we want a mixed number, shift and then the fraction button. So 2 and 1/3 will look something like so. So that's 2 and 1/3. What it's done for me here is written it as 7 over 3. It's converted the mixed number into a top-heavy or improper fraction. A top-heavy or improper fraction is when the numerator is greater than the denominator. So let's see how we could convert this into a top-heavy fraction. All we do is simply multiply the denominator by the integer value. 3 times by 2 is going to give me 6. 6 plus 1 gives me 7, so we get 7 over 3. Let's look at how that happened. As much again as mathematicians dislike pizzas, if we've got 2 whole pizzas and we split them into thirds, in each pizza we have 3 thirds. So if I have 2 pizzas, I've got a total of 3 thirds and 3 thirds, which is 6 thirds, and then I've got 1/3 as well, and then we simply add these up. So that's 3 thirds, 3 thirds and 1/3, which gives me 7 thirds. So for every one or every whole number I have, I've got 3 in there. So 3 thirds make 1 whole. So if I had 6 and 2/5, 5 times by 6 gives me 30 plus 2, and that gives me 32 over 5. So that is a top-heavy fraction. So what we've done here is converted a mixed number into a top-heavy fraction. Let's look at reversing that and writing a mixed number from a top-heavy fraction. So for example, if I had 5/3 and I wanted to write this as a mixed number, the easiest way for me to do this is to see how many times 3 goes into 5. Well, 3 goes into 5 once with a remainder of 2. So what we've got here is 3/3 plus 2/3. So this gives us 1 whole one, and we're left with 2/3. So 5/3 can be written as 1 whole one and 2/3. If we have, for example, let's go for 11 over 4. Well, 4, 8, 12. So 4 will go into 11 twice. We will have 2 whole ones and a remainder of 3. So we get 2 3/4. So that is just taking now a top-heavy fraction or improper fraction and writing it as a mixed number. Remember as well, as I think this is quite important, if you have 6 over 6, 6 over 6 just gives us 1. If we have, for example, 4 over 4, this is 1 whole. So converting mixed numbers to top-heavy fractions and converting the top-heavy fractions into mixed numbers. So if we go ahead and look at 11 over 4, and I can just do 11 divided by 4. 11 divided by 4 does that. So if we hit S to D, it will give me now the decimal. If we hit Shift and S to D, it will give me it as a mixed number. So nice and straightforward, and we go ahead and do that. So let's now look at ordering fractions. This is often done on a non-calculator paper, and all we do is look to find a common denominator. So at the moment, we're asked to put these fractions in ascending order. Ascending means from smallest to largest. What we've got here is 2/5, 9/15, 7/10, and a half. If you wanted to do that on a calculator, you could simply type them in and get a decimal answer. If you're going to do it with a calculator, and it's on a calculator paper, that's fine. Just make sure you're keeping a certain level of accuracy, because some might be very close. If it's a non-calculator problem, what we need to do is find the common denominator. I've got 5, I've got 15, I've got 10, and I've got 2. So what I want to do is have the same denominator for each fraction, so we can simply compare the numerators. The one with the largest numerator is the greatest, the one with the smallest is the smallest or the lowest. So let's find the lowest common multiple of 5, 15, 10 and 2. Looking at that, that is going to be 30. So the lowest common multiple or least common multiple is going to give us now 30. All I'm going to do is write equivalent fractions. So if I've got 2 over 5, I need to multiply the numerator and the denominator by 6. Multiplying 5 by 6 gives me my 30. So whatever I do to the bottom, I must do to the top. 6 times 2 is 12. If we look here, we've got 9 over 15. I need to multiply the denominator by 2, which will give me 30. So I need to multiply the numerator by 2, which gives me 18. We've got 7 over 10. We would need to multiply 10 by 3, so that would give me 30. I need to multiply by 7 by 3, 21. 2, I'd need to multiply by 15, so we get 30. So I need to multiply the numerator by 15, and I get 15. So all we have to do now is look at these and see which is the smallest. This is the smallest, then this one, then this one, then this one. So when I write out my answer, I write out 2/5, then I write 1/2, then I write 9/15, and then I write 7/10. So I'm writing back exactly the form I was given. This is my working, and then my final answer is just here. Don't be tempted to write these as the answers. These are the answers in ascending order. If it was descending order, we'd have this one first, then this one, and this one right here. Okay, let's now look at finding a fraction of a quantity. We can do it with a calculator or without. Let's start off by using a non-calculator or not using a calculator. What we're going to do is find 1/4 of 20. So if we have 20 quid and we want to find a quarter of it, we simply divide by the denominator of the fraction. So we take the 20 and divide by 4. 20 divided by 4 is going to give us 5. So we can say 1/4 of £20 is £5. So if I wanted 3/4 of £20, I know that 1/4 is 5. I would simply multiply 5 by 3, and that would give me 15. So all I'm doing is dividing by the denominator and multiplying by the numerator. So if I wanted, for example, 5/8 of, let's say we've got, let's go for 16. All I'm going to do is 1/8. 16 divided by 8 is 2. So 1/8 is 2. So 5 lots of 2 gives me 10. So I've divided by 8 and then multiplied by 5. So 5/8 of 16 is going to give us 10. If we look at another one, let's say we wanted 4/7 of, and we'll go for £28. 1/7 is going to be 28 divided by 7 gives us 4. So 1/7 is £4. So 4/7 is simply going to be 4 times by 4, which gives me 16. So that's a non-calculator example. If we're looking at a calculator example, when we hear the word of in maths, we simply multiply. So grabbing the calculator, let's say I wanted 7/8 of a number, and let's say that number, for example, was going to be 120. All I do is type it in. 7/8 of 120 is 7/8 multiplied by 120, which gives us 105. If I wanted 13/17, for example, of 176, that's all I would need to type in, and that gives us 134.6, correct to 1 decimal place. So in maths, when you see the word of, you can multiply. So that's finding a fraction of a quantity with a calculator. This comes up quite a lot in exams, so we'll look at some typical exam style questions. So let's go ahead and look at the first one. Pete and Sue have some lemonade. Pete gives 250 ml to Sue, which leaves her with double what she started. Sue drinks 1/10 of her lemonade. How much more lemonade would she now need, or would she need to now make a litre? So if he's given her 250, let's go ahead and do that. He's given her 250, and this is doubled what she had. She must have had 250 as well, which gives 500 ml. So what we've got is 500 ml. Sue drinks 1/10. 1/10 of 500 is going to be equal to 50 ml. So she has now, and we can write this down, she has a total of 450 ml. We've got to work out how much more lemonade she would need to make a litre. 1 litre is 1,000 millilitres. 1,000 millilitres minus 450 millilitres is going to be equal to 550 millilitres. So all we've done is simply found 1/10 of the combined amount and then subtracted that and worked out how much more she would needed to have had. Hopefully that 250 plus the 250 was relatively straightforward. If you were unsure and your algebra skills were good, you could have said x plus 250 must be equal now to 2x. All we're doing here is simply doubling up what we've got. So what she started with plus 250 gave us twice what she started with. So subtracting x from both sides, we can see that 250 was x. So it'd be 250 plus 250, so she would have a total of 500. Again, I think it's easier not to use that method, but if you were unsure, you could have used algebra. So that's one way of doing it. Obviously different ways, but you can do it that way. Question number 5. Bob has a sink that is half full. He fills it up to the top with 2,400 ml. Write down the capacity of the sink in litres. So the capacity is the amount that we can get in it. So all we've got to do now is think logically about this. This is reverse, working in reverse. So let's just go ahead and get a little diagram. What we've got in this question is this sink, and we'll just draw it like so. So here's the sink. What we're told, this is currently half full. So what we've got is half full, and he can fill it to the top with 2,400 ml. So if this is half full, this represents 1/2, and what's left over is going to be 1/2. If you're unsure what a full one makes in general, simply subtract the fractions that you've got from 1. So for example, if we were told that a tank, let's just write this down, a tank had 1/3 water and it had 1/4, let's say, I don't know, juice, and we wanted to know how much was left over, all we would simply do is do 1 minus 1/3 and then minus another quarter, and that would tell us how much is left. We'll look at adding and subtracting fractions without a calculator later, but we could tell that there's 5/12 of the tank still empty. So let's just look at this diagram. So he fills it to the top with 2,400 millilitres. So 2,400 millilitres is equal to 1/2. So that must mean that this one is equal to 2,400 millilitres as well. So the capacity of the tank is simply going to be 4,800 millilitres. So 1/2 represents 2,400. So we could say now that the total capacity is 2 times that. We need to give our answer in litres, so this will be 4.8 litres. There are 1,000 millilitres in a litre. Let's look at the next one. An oil tank is 1/4 full. The tank still has room for an extra 480 litres. We're asked to find the capacity of the tank. So yet again, we're working in reverse. A quick diagram with some fractions may help us. So if we put these on, it'll look something like so. So what we've got now is that the tank is 1/4 full. This doesn't have to be brilliant, it just has to give us some idea of what's going on. So what we've got here is 1/4, and all of these now can be represented as quarters. So what we've got here is 1/4, 1/4, 1/4, and 1/4. So these are the empty spaces, and this is the full part. So what we can see then is that 3/4 of the tank would be equal to 480 litres. What we need to do is find what 1/4 is. If 3/4 is equal to 480, what we can do is divide by 3, as we know we've got 3 sections, and 1/4 is 480 divided by 3. 480 divided by 3 is going to be 160. The common mistake here is to divide by 4. It's telling us that 3/4 of this amount is equal to 480. So we just divide by 3 to find 1/4. So quite clearly now that we can see on here, we've got 4/4. So 4/4, which is equal to 1/2, will give us now 160 times by 4, which should give us 640. If you've got a calculator, you can simply do 480 divided by 3/4, and that will give you now the value. So 640 is what we get. So that's what it is. So if I said now 4/5 of a number is going to be equal to 20, and we wanted to know what that number is, all we would do is simply divide by 4. So we could say 1/5 is equal to 20 divided by 4, which gives us 5. So 5/5 or 1/2 is going to be 5 times by 5, which is 20. So 4/5 of a number is 20. So we can simply say that 5/5 or 1/2 of that number will be 25. Later we will look at simple equations, setting up simple equations to find those values. But for now, that's a more manual way of doing it. So that is finding a fraction of a quantity. Let's now move on, and we're going to look at adding fractions and adding mixed numbers. If we're adding fractions or mixed numbers, we need to ensure that the denominator of the two or more fractions are the same. So if we look here, we've got 1/3 plus 1/3. We can see that in both cases the denominator is 3. If that's the case, we simply add the numerators. So 1/3 plus 1/3 is going to give me 2/3. A common error is that students write 2/6. 2/6, if you simplify it, is 1/3. So if the denominators are the same, we simply add the numerators. 2/5 plus 1/5 is simply going to give me 3/5. 4/7 plus 2/7 will give me 6/7. If we look at the next one, we've got different denominators. What we're going to do is look at a couple of different ways without a calculator for us to be able to add fractions with different denominators. The first way is to think about equivalent fractions. So if I look, 4 and 8 have a lowest common multiple of 8. So the lowest common multiple is the first number that both 4 and 8 go into. All I have to do is change the fractions. So here, instead of 3/4, I can double this up and write this now as 6/8. So all I've done is multiplied the denominator by 2 and the numerator by 2. I can leave 1/8 as it is. So 3/4 becomes 6/8 plus 1/8 is going to give me 7/8. So that's the first approach, and that's getting equivalent fractions. An alternative approach, although I don't like this as much, if we take now 3/4 and we add to it 1/8, we multiply the left-hand fraction by the right-hand denominator, and we multiply the right-hand fraction by the left-hand denominator. If I do that, I'm going to do 8 times by 3 and 8 times by 4. That gives me 24/32. Then I multiply the right now by the 4, so the numerator and the denominator, so that's going to give me 4/32. If I go ahead and do that, that is going to give me 28/32. And at this stage, we would need to simplify. I can divide both of these now by 4. 28 divided by 4 is 7. 32 divided by 4 is 8. So that is essentially cross-multiplying. As you can see, this method is significantly quicker for this type of example, where we've only got one of the denominators to change. So let's look at this one. We've got 1/3 plus 2 ninths. So 1/3 plus 2 ninths. Lowest common multiple of 3 and 9 is 9. So all I'm going to do is change this fraction into an equivalent fraction over 9. So instead of 1/3, that would be 3/9. 3/9 plus 2/9, well, that is just going to give me 5/9. Again, we could have multiplied. So if we look at this, what we would have is 1 over 3 plus 2 over 9. I would multiply all of this fraction by the 9, and I'd multiply all of this fraction by the 3. If I do that, what I'm going to have is 9 over 27 plus, we're going to have 6 over 27. So that gives me 15 over 27. Both of these are divisible by 3, and we're going to end up with 5 in the numerator, 9 in the denominator. As you can see, that's a lot longer to do. If we look at 2/3 plus 1/5, this time both now are not. So I can't turn the 3 into 5, but if I use the lowest common multiple method, what we're going to have, the lowest common multiple of 3 and 5 is 15. So if I converted these into 15ths, we would need to multiply this one by 5, and that would give me 10 15ths. This one here, I would need to multiply this by 3, and that would give me 3 15ths. 10 15ths plus 3 15ths is 13 15ths. All you could have done is simply now looked at it as 2 over 3 plus 1 over 5. So we'd multiply all of this one by 5, and then all of this one by 3. So if we'd done that, we would have got 10 over 15 plus 3 over 15. In doing that though, we won't always have the lowest common multiple, and it might lead to a lot of cancelling. An example is this one just here. The lowest common multiple is of 4 and 6 is 12. That's the first number they both go into. So if I wanted this into 12s, I would just multiply it by 3. So that would give me 9 over 12. If I wanted to get this one into 12s, I would simply double the numerator and the denominator, and I would get 10 over 12. That's going to give me 19 over 12, or we could say 1 whole as a mixed number and 7 12ths. If you'd gone and simply multiplied across with the 3 over 4 plus now, what did we have? 3 over 4 plus the 5 over 6. If we'd multiplied all of this side by 6 and all of this side by 4, we would have had 18 over 24 plus 20 over 24, which would have given us 38 over 24, which would need simplifying. So it is easier finding the lowest common multiple, but I appreciate that some people prefer to do it this way. On a calculator, clearly we can just type these in. 2 over 5, for example, plus 1 over 3. So just typing it in, we would get now a simplified fraction, and it will do it for us in its lowest form. So that's adding fractions. When we're adding mixed numbers, there are a couple of different approaches. You can add the integer parts. So for example here, I can do 1 plus 2, which is 3. Then I can do the 3/4, and if I just write this here, 3/4 plus now the 1/3. So if I do 3/4 plus 1/3, the common denominator is 12. So this is going to be 9 over 12. And this one is going to be 4 over 12. 9 over 12 plus 4 over 12 gives me 13 over 12, or we can say 1 and 1/12. So at this stage, I simply need to bring the 3 down and add it back. So 3 plus 1 and 1/12 will be 4 and 1/12. Alternatively, what I could have done is written these now as instead of mixed numbers, as top-heavy fractions. So 4 times 1 plus 3, that would give me 7 over 4. 2 times by 3 plus a 1 would give me now 7 over 3. So at this stage, I would simply now put these into 12s. So this would be, now multiplying this one by 3, this would be 21 over 12. Multiplying this one by 4, that would give me 28 over 12. That gives me a total now of 49 over 12. 12 goes into 49 4 times with a remainder of 1. So we could say this is 4 and 1/12. Same answer. And certainly when it comes to the subtraction of mixed numbers, I would prefer this approach. So on this one, you could do 5 plus 3 and then add the fractions, or convert these into top-heavy fractions. This one here, 3/4 plus 3 and 1/7, again, entirely up to you. Remember, if you're going to convert this, this is going to be 22 over 7. So let's look at question 16. At a school, 1/3 of the pupils are in year 7 and 1/2 of the pupils are in year 8. How many pupils are not in year 7 or year 8 at the school? So this would be a typical non-calculator question. So what we've got then is the year, and often just writing this down so you can see what you've got, and what we'll have is the other years. So on here we've got in year 7, we've got 1/3. In year 8 we've got 1/2. All of these now must add up to 1. So all we would need to do is simply add these two together and subtract them from 1. You can of course subtract them individually. I think if we just add these together and take them away from 1, that would be easier. So 1/3 plus 1/2. So lowest common multiple is 6. So this is going to give me 2 over 6 plus 3 over 6. So that gives me 5 over 6. So the number of students in year 7 and year 8 is 5 over 6. So all we need to do to find the other years is simply do 1 minus 5 over 6. Remember, 1 is 6 sixes, that's a whole, minus 5 over 6 will give us 1 over 6. So a few different ways that you could do that, but that's relatively straightforward once we write it all out. So when you're adding fractions, we must have a common denominator. Let's now move on and look at subtracting fractions and mixed numbers. Exactly the same is true for subtraction. With addition and subtraction of fractions, the denominators must be the same. So if we've got 3/5 minus 2/5, we simply now subtract the numerators. So 3 minus 2 is 1, that will give us 1/5. 3/4 minus 1/4 will give me 2/4, which we could of course write as 1/2 as a simplified fraction. If we now look at this one, we've got different denominators. So adding and subtracting fractions requires the same denominator. So with this one, we've got 12 and 3. Lowest common multiple of 12 and 3 is 12. So if I write now 7 over 12 minus, I'd need to multiply this one by 4 to get 4 over 12. So all I've done is converted this into an equivalent fraction over 12. This gives me 3 over 12. I'm simply subtracting the numerators, and we could simplify this to 1 over 4. So same technique as before, but instead of adding the numerators, we're subtracting. Again, with this one, you could have cross multiplied. So if we look at this, if I did that, we would multiply all of this side by 3 and all of this side by 12. So we would have 21 over 36, and we would subtract from that now 12 over 36. That's going to give me 9 over 36, which we can cancel dividing the numerator and the denominator by 9, 1 over 4. As you can see though, it's easier just to convert this. 12 and 6, we could switch those up into 12s. 3 and 4, I would personally put these over 12. And this one will do. So 4 over 5 minus 3 over 4. Lowest common multiple is 20. So if I multiply this one by 4, we would have 16 over 20. Multiplying this one by 5, we'd have 15 over 20. 16 over 20 minus 15 over 20 is 1 over 20. Again, you can do these on a calculator. Okay, let's look at subtracting mixed numbers. With a calculator, we could go ahead and simply type in the first one, 4 3/4 minus 1 1/2. So all I'm doing is hitting Shift and the fraction button, and we can type these in. So 1 1/2, and that is going to give us now 13/4. If we hit the S to D, that's 3 1/4. You could do exactly the same with adding these. So all we could do is swap that over and it would add them for us. So that's what we end up with. Let's now look at doing this without a calculator. A couple of different approaches. I personally find it easier to convert these to top-heavy or improper fractions. So 4 times by 4, add the 3, that gives me 19/4. 2 times 1 plus a 1, and that gives me 3/2. So we need a common denominator, and if we look at this, we can simply double this one up. So we have 19/4 minus, and this one is going to be 6/4. So all I've done is times that or multiply that by 2. This is going to give us 13, that's 19 minus 6/4. We know that 4 will go into 13 3 times and a remainder of 1. So this is 3 1/4 as we saw from the calculator. So let's just do that, and that's what we get, 3.25 or 3 1/4. With the next one, what we'd have here is 15 plus 1, which is 16/3. 4 times by 3 plus 1 is 13/4. Lowest common multiple of these is 12. So if I multiply this one by 4, that would give me 64/12. Multiply this one by 3, that gives me 39/12. That's going to give me 25/12. Or we could say this is going to give me 2 whole ones and 1 12. So 2 whole ones and 1 12. So that's what we end up with. And again, you can check that on a calculator. Let's look at some typical exam style questions that we might get on a non-calculator paper. In question 1, it says, at a youth club, there are 3 age categories: 10 and under, 11 to 15, and over 15. 2/3 of the members are in the 10 and under, 1/6 in the 11 to 15, and the rest are over 15. What fraction of the members are in the over 15 section? So this is exactly the same as we saw before. So the first section, we've got the 10 and under. We've got a total now on here if on, what's this one, 2/3 from there. So 2/3 in the 10 and under. In the second category, which is the 11 to 15, we've got 1/6. And then finally, the last bracket, or the last age section, we've got now to find that. So all we've got to do, again, is 1 minus 2/3 minus 1/6. So what we could do, again, is add these together. If I add these together, we would get now 2/3 and 1/6. So if I did 2/3 plus 1/6, we would get 4/6 plus 1/6, which is 5/6. So 1 minus 5/6 is going to give me 1/6. I think that was the same answer as we had before. But again, we can see how to do that. You could do 1 minus, if you really wanted, you could do this step by step. Remember, 1 minus 2/3, this is 3/3 minus now 2/3. So 3/3 minus 2/3 is 1/3. Then all we would do is subtract 1/6. So we'd have 2/6 minus 1/6, which of course gives us 1/6. Let's look at this one. Fred has 7/8 of a bag of sweets at home. He eats 1/5 of the remaining sweets. What fraction of the bag of sweets has he now got left? So all we need to do here, he's got 7/8. So 7/8 minus, he eats 1/5 of the remaining sweets. So we take away 1/5. lowest common multiple of 8 and 5 is 40. So multiplying this one by 5, that's 35 over 40. Multiplying this one by 8, that's 8 over 40. So 35 minus 8 gives me 27 over 40. Can we simplify that? Well, 27 is divisible by 1, 3, 9 and 27. And 40 doesn't have any of those as factors other than 1. So that would be a simplified fraction. You can check that on a calculator. 27 divided by 40. And that gives us 27/40. So the take-home message is that when we're adding or subtracting fractions or mixed numbers, the denominators have to be the same. Let's move on now and look at multiplying fractions. When you're multiplying or dividing fractions, you don't have to have a common denominator. All we do when we multiply is simply multiply the numerators and then multiply the denominators. So in this particular case, we've got 1 times 1 over 2 times by 3. So 1 times by 1 is 1, and then 2 times by 3 is 6. So 1/2 times by 1/3 is 1/6. Another way to think about this, just to check if you're right, remember in maths, multiply can be written as of. So if we had 1/2 of a third, so if a pizza was split into 3 parts and we had 1/2 of that, we'd have 1/6. When we are multiplying fractions, we can cancel. Certainly at this level, cancelling is not necessarily promoted. Certainly if you take your maths on, it may be. And we'll look at cancelling before we carry out the calculation, or simplifying at the end. 2/3 times by 1/7. 2 times by 1 is 2. 3 times by 7 is 21, and it gives us 2 over 21. If we look at the next one, there are 2 particular approaches we could take. If we wanted this in its simplest form, we could carry out the calculation and then simplify at the end, or we could cancel off to begin with. Let's just look at the method I've introduced. 2 times by 1 is 2. 2 times by 3, or 3 times by 2 is 6. 2 over 6 we can simplify to 1 over 3. What we're now going to do is look at a more advanced approach. Certainly when the calculations get more complicated, it's easier to cancel off before you carry out the calculation. When you're multiplying fractions, you can either cancel vertically or diagonally. So if we look here, what we've got is 2 over 3, and then we've got times 1 over 2. What I could do here is cancel diagonally. 2 and 2 have the common factor of 2. If we divide both of those by 2, we'll have 1 and 1. What this now leaves me is 1 times by 1, which is 1, and 3 times by 1, which is 3. So you can see that we don't have to cancel at the end. If I had, for example, 4 over 8 times by 3 over 5, we could cancel this one vertically. So I know that 4 over 8, 4 goes into 8 twice, so we could write this as 1 over 2 as a simplified fraction. All we'll get is 1 times by 3, which is going to give us 3, 2 times by 5, which is going to give us 10. We could have, of course, simply done it as 4 times by 3, which is 12, over 8 times by 5, which is 40. What we'd then have to do is simplify this and look for common factors. That would be perfectly fine. If we wanted to do that, we could divide both of these by 4, and that would give us 3 over 10. Certainly if you're taking your maths on, to be able to spot those common factors would be good. Let's look at this one. No common factors. 3 times by 3 is 9. 4 times by 5 is 20. This one, we have common factors, but we could just do 3 times by 1, which is 3. 5 times by 6, which is 30. This would simplify down to 1 over 10. What we could have done here is spotted that 3 and 6 could be 1 and 2. If we look at this one, that would give me 14 over 24, which we could simplify, or we could cancel the 2 and the 8 to 1 and 4. 1 times by 7, 3 times by 4, 7 over 12. This one here, we would get 8 over 7 times 7 over 8, 56 over 56, which is 1. Alternatively, 8 over 8 will give us 1 over 1. 7 over 7 will give us 1 over 1. 1 times 1 over 1 times 1 is 1, which of course is 1. Okay, let's look at this. What we've got here is an integer, so a whole number, multiplied by a fraction. Students often multiply both of these at this stage. All I would suggest doing is writing 4 over 1, so writing this as a top-heavy fraction, and multiplying by the 7 over 3. 4 times by 7 is 28, 1 times by 3 is 3, so we'd have 28 over 3, which of course we could write, if we wanted, as a mixed number, so that is 9 whole ones and 1 third. Exactly the same here. We would have 6 over 1, so it would be 18 over 5. With this one, no different. We could simply multiply the numerators. 1 times 4 times 2 is going to be 8. 2 times 7, that's going to give me 14. 3 times by 14 is 42. We could go ahead and simply divide this now by, what could we divide that by? 4, 2. That would give me 4 over 21. Alternatively, you could have spotted that the 2 and the 2 will cancel to 1 and 1. So that way we would have got that. Right, let's look at multiplying mixed numbers. Again, if we've got a calculator, multiplying mixed numbers will be straightforward. 1 and 2/5 multiplied by the 3 and 2/3. So all I'm doing is typing this in, and it will give us now this as a top-heavy fraction, which we can go ahead and convert to a mixed number. So let's now look at doing this without a calculator. What I'm going to do here is write these as improper or top-heavy fractions. So what we're going to have then is the following. We're going to have 1 times by 5, which is 5, plus the 2. So that's going to give me 7 over 5. 3 times by 3, which is 9, plus a 2 is going to be 11 over 3. So if I look at this, 7 times 11, 77. 5 times by 3 is going to give me 15. 15 goes in 5 times with a remainder of 2, so we get 5 and 2/15. Let's just check that. We had our answer in here, didn't we? There we go, 77. And that's 5 and 2/15. If you do cancel something, remember you can bring the answer back by just doing that. Also, students, for some reason, let's say they've got a couple of calculations. So let's say they've got 17 divided by 4, and it comes up to be 4.25, and they may need to multiply this by 2. What they do is they can do 2 times by 4.5 and do it that way. You can just use your answer. So if we did 17 divided by 4, for example, all we would have to do is 2 lots of the answer, or 2 times the answer, and it'll do it for us. So do get used to doing that. You can store numbers in as well if you wanted. Let's say we've got 52.364, whatever, and that's our number. If you hit Shift, Store, A, it will stay in there as A. So if I clear this, so if I just clear this, and then I type in some numbers, do a few calculations, and then I wanted to divide it by 2, for example, and then I think, oh, actually I needed A back. If we just hit recall A, it will bring it back. So we can go ahead and do that. If you wanted this one, you can do Shift Store B right the way up to, on here, F. So that is storing them in. So that's what we get. This one, again, we would simply write this now as 25 over 6 times by 12. So this, let's actually do this one. This is 25 over 6. And then we would get now times by 12 over 5. This one looks fantastic for cancelling. If you're now confident to cancel, 25 over 5 gives us 5 over 1. 12 over 6 will give us 2 over 1. So we just end up now with 5 times by 2, which is 10, over 1 times by 1, which is 1, which gives us 10. So that's quite a nice one. You didn't have to do it that way, but if you've gone the long way, 25 times by 12 is 300, 6 times by 5 is 30, and 300 over 30 will give us 10. Hopefully, if you are at this stage, you're happy to cancel. So what I can do is now, if I have a 0 in the numerator and a 0 in the denominator, I can cancel those off. All that's representing is that I'm dividing both the numerator and the denominator by 10. So this would give us now 30 over 3, which we know is 10. So for example, if you have 2, 4, 5, 0 over, let's say, 50, we can simply divide the numerator and the denominator by 10, and it would be 2, 4, 5 over 5, which you may find easier to simplify. Let's have a look at a word-based question that would come on a non-calculator paper. Jane ate 1/3 of 2/5 of a cake. What fraction of the cake did she eat? 1/3 of 2/5. Hopefully now you're happy replacing this with a multiplication sign. So it's just 1/3 times by 2/5. 1 times by 2 is 2, 3 times by 5 is 15. She ate 2/15 of the cake. As you can see, we've got no common factors vertically or diagonally to cancel, so it's just 2/15. So that is multiplying fractions or mixed numbers. Let's now look at dividing with fractions and mixed numbers. This is very similar to the multiplication of fractions. The first thing is we don't need a common denominator. You only need a common denominator when you're adding and subtracting fractions. Let's take the first one. What we've got is 1/3 divided by 1/2. Let's just look at this a slightly different way before we proceed. If I've got 2 pizzas and I want to know how many halves I can get out of those 2 pizzas, we could write this as how many times does 1/2 go into 2. If we just drew the pizzas, and again I appreciate some mathematicians hate pizzas, the answer is if I have 2 pizzas I would have 1, 2, 3, 4 halves. So a half goes into 2 4 times. So all I could do here, instead of writing 2 divided by a half, I could actually write 2 times by 2, or 2 over 1. When we're dividing fractions, we could simply multiply by the reciprocal. Remember, the reciprocal is the fraction inverted or turned upside down. So if we look at this one right here, we've got 1/3 divided by 1/2. An equivalent statement is 1/3 times by 2, or 2 over 1. 1 times by 2 is 2, 3 times by 1 is 3, so we get 2/3 as our answer. So 1/3 divided by 1/2 gives us now 2/3. Let's look at the next one. 1/5 divided by 1/4. We could write this as 1/5 times by 4 over 1. We're simply turning the second fraction and multiplying. Often you might want to think about this now as turn and times. Turn the second fraction and times. If you want a memory aid, 1 times by 4, that gives me 4. 5 times by 1, 5. So 1/5 divided by 1/4 is 4/5. 2/5 divided by 1/2 is the same as 2/5 times by 2 over 1. 2 times by 2 is 4, 5 times by 1 is 5. Let's just look at this one here where we have an integer. What we have here is 9/7 divided by 3, and I could write this as 3 over 1. This is the same as doing 9 over 7 multiplied by 1 over 3. We could cancel off at this stage, or we could simply carry out the calculation. 9 times by 1 over 7 times by 3 is 9 over 21, which gives us now 3 over 7. Do be careful with these. Don't cancel off unless you've inverted the fraction and you're multiplying. 4, let's look at this one. 4, and we'll write this as 4 over 1 divided by 1 over 5. This is the same as doing 4 over 1, or just 4 times by 5 over 1. And that's just going to give us 20 over 1, which gives us 20. Again, common error, students write 1 times 1 is 2 and end up with something totally different. So that's what we have. Hopefully you can see 9/7 divided by 9/7. Well, the answer should be 1. But if we look at this, we'll see why. 9 over 7 times by 7 over 9. So all I've done is inverted or turn the fraction round. So you can see here that would give us 63 over 63, which is 1, or we could cancel those 9s, put those as 1s, cancel those 7s and put those as 1. 1 times 1 over 1 times 1 is 1. Let's now look at dividing with mixed numbers. In this particular case, I would simply turn these into top-heavy fractions, so improper fractions, and carry out the calculation. 2 times by 3, or 3 times by 2, is 6, plus a 1. We would get 7 over 3, divided by 5 times by 1 plus 1, we would get 6 over 5. So we could write this now as, in fact, let's put it below. Let's just go ahead and write that below. We could have, instead of 7 over 3, we would have 7 over, or instead of 7 over 3 divided by 6 over 5, we could have just like so. So I've inverted the fraction and multiplied. So 7 times by 5 is 35. We've got 3 times by 6, which is 18. If you wanted this now as a mixed number, we would have 1 whole 1 and 17 over 18. That looks good. And that's how we'd do. So that time we've simply converted them to top-heavy fractions, inverted the fraction and multiplied, and then gone ahead. You don't turn both fractions round, it's just the second. So let's do a wordy exam style question. Kevin is seeing how many 8ths he can cut from 1/4 of a cake. How many would you expect him to be able to cut? So what he's doing is seeing how many 8ths he can get out of 1/4. So the calculation is 1/4 divided by 1 over 8. This is saying how many 8ths go into 1/4. So we could write this as 1/4 times by 8, or 8 over 1. If you want to cancel down, you can do. Otherwise, this would give us 8 over 4, and 8 over 4 is 2. So relatively straightforward once you've got those skills. So let's just recap. Adding and subtracting fractions and mixed numbers, we need a common denominator. Once we have the common denominator, if we're adding, we add the numerators. If we're subtracting, we subtract the numerators. When we're multiplying, we simply multiply the numerators and multiply the denominators. When we're dividing by a fraction, we simply invert or turn the second fraction upside down and multiply. Okay, let's move on. We're now going to look at finding a percentage of a quantity. We'll start off with some non-calculator examples and then move on to some calculator examples. On a non-calculator paper, we'll be expected to find a percentage of a quantity using 10%, 5% and 1% multiples. So let's start off and have a look at an example. So let's say I have £540. If I've got £540, we can go ahead without a calculator and find different percentages of this value. So if we think about this, 100% of the value is going to be equal to £540. If we want 10%, we can divide both of these by 10 and that's going to give me now 100% dividing by 10 gives me 10%. Dividing £540 by 10 is going to give me £54. If we wanted to find 5%, for example, 5% would be half of 10%. So all I'm doing is dividing the left-hand side by 2, and I would do exactly the same with the right-hand side. We can get 1% from this, so let's go ahead and move this down. We can get 1% by simply dividing 10% by 10, and 1% is going to be, instead of 54, we will have 5.4 or £5.40. So all I've done is taken 100%, find 10%, find 5% and found 1%. Of course, you could have 50% by halving the 100%, you could have 20% and so on and so forth. So if we were asked to find, for example, 15% of £540, all we would do is simply take one lot of 10% and add to that one lot of 5%. So this would be the £54 plus now the £27, and that would give us a total now of £81. So we can say 15% is £81. If I wanted 16%, all I would do is have the 10% plus the 5% and plus 1%. So of course, that would just mean adding £5.40 here. So we would have now £86.40. We can find most values by doing that. Some will be a bit more fiddly than others, but we can either add or subtract those values. So typical kind of non-calculator question here, question number 14. It says show that 25% of 44 is more, or £44 is more than 10% of £111. What we could do here is find 10%, 10% and 5%, or we could simply divide £44 by 4. So 25% is going to be 1/4. So you can either do it this way, or you can say now 25% is going to be equal to 1/4. So we'll have now 1/4 of 44, which is going to give us now 11. So 1/4 of £44 is £11. If you've gone the other way, what we could have said now is, and I'll just put it here, 10% is going to be £4.40, so 4.4, £4.40. We would have now 5% is going to be half of this, which is going to be £2.20, and we could add 2 of these and 1 of these. I still think it's quicker to consider now that percentage as a fraction. If we look now at 10% of 111, so 10% of 111, so 111 is going to be now £11, and just writing this in, £11, and we're going to have on here £11 and 10 pence. So it says here, show that 25% of £44 is more. Well, it's not. So I think that question must be wrong. It certainly isn't. We've got £11 versus £11.10. I think we need to switch these over, don't we? Show that 10% of £111 is more than 25% of 44. So a typical kind of question, of course, if it was right, to do that. So finding 10%, we divide by 10. Finding 25%, you can divide by 4, or you can find multiples of these right here. Okay, let's have a look at some more questions. Let's just get ourselves some space. So on the next part here, what we've got, it says Jill buys some seeds. There are 50 seeds and 80% blossom into flowers. She can sell each flower for 80p. The seeds cost her £6.70. Find how much profit she would make if she sold all of the flowers. So let's go ahead and look at this. 50 seeds and 80% blossom. So what we need is 80% of 50. So 80% of 50, and this would be a non-calculator question. If we think about it now, and I'll just write it here, 10% of 50 is going to be equal to 5. So if 10% is equal to 5, 80% is just 8 times by this, so 80% would be 40. I'm just multiplying this by 5. So what we'll have is 40 flowers. What we're now going to do is multiply the 40 by 80p. It says here that the seeds cost us £6.70. You might want to work in pence first and convert to pounds, or you can convert this to pounds. So we'll have 40 flowers times by 80p, or £0.8. This is going to give me £32. So we get £32 from selling these flowers. We need to find the profit. Well, we've taken 32, but we spent £6.70, so we can say that the profit is going to be now equal to £32 minus £6.70, which is going to give us now £25.30. So all we've done is found 80% of a number and done that question in context. Okay, let's look at another one. In question 9, it says, at a school, 0.25 of the boys, so 0.25 of the boys, 0.25 of the people are boys, it should say, one half are girls, 15% are TAs, and the rest are teachers. Given that there are 20 teachers, find how many more girls there are than boys at the school. This question is slightly harder. What we need to establish here is what fraction or percent of the people at the school are teachers. So what we've got here is 0.25. So if we look at this, we've got boys, we've got girls, we've got TAs, and we've got teachers. So 25% are boys, so 0.25. Half are girls, 50% are girls. 15% are TAs. If we add this up, this is 75%, 90%. Therefore, the teachers must be 10%. These must all equal up to 100%. They're either boys, girls, TAs, or teachers. So what we can say then is that 10% will be equal to 20. So if 10% is equal to 20, 100% must be equal to 200. So in total, there are 200 students in there. So if we know that 200 students are in the school, what we can do is simply look at the boys and the girls. So 50% of 200 is going to give me 100. 25% of 200 is going to give me 50. So how many more girls are there than boys at the school? 100 minus 50, and that is going to give us 50. So that one is working backwards. Okay, let's look at the next one. The table below shows the cost of cinema tickets. A family ticket consists of 2 adult tickets and 2 child tickets. 15% discount is offered if you buy a family ticket. Find the cost of buying a family ticket. So what we need to do here is go ahead and find the total cost. You can apply for 15% discount straight away. I think it's easier if we work out the total cost and do it at the end. So if we have 2 adult tickets, this would be 2 lots of £4.80. So 2 lots of £4.80 is going to give me £9.60. If we do 2 lots of a child tickets, this is 2 lots of £3.60, which is going to give me £7.20. If we look at this in total, adding these up, we can say now that the total is going to be equal to, adding this up, we're going to get £16.80. So £16.80. What we need to do is find 15% and take this off. A 15% discount is given. So if we look at this now, this is our total. We can say that 10% is going to be 1/10 of this. Remember, this is 100%, So 10% is going to be £1.68. 5% will be half of that, and that is going to be 84p. So all we're doing here is simply taking 5% and 10%. So 15% is going to be these two values added up. If we go ahead and add those up, that's going to give me a total of, that's going to give me that's going to give me £2.52. So if you want to do it with, and let's just move this down, if you want to do it by adding, if you want to add downwards with column, let's make that a bit smaller, with column addition you can do, let's just get that back, and we'll make that a bit smaller. So if you were unsure on adding those, you can just add downwards. So if we look at adding downwards, we could add now the 8 and the 4, which is going to give us 12. We've got now 6 and 8, which is going to give us 14, plus a 1, which is going to give us the 15. Then we get now 1 added over, and we get £2.52. So £2.52, that's what we get, and we need to go ahead and subtract it. So our final value will be £16.80, and we're going to subtract from that now £2.52. You don't have to have the 0 there, you can if you want. So if we go ahead and do this, we can borrow, so that's going to give us 8, that will give us 2, this will give us 4, and this will give us 1. So it'll be £14.28 in total. So a typical non-calculator question looking at a percentage of a quantity. We'll go on to look at percentage increase and decrease shortly, but that's a typical example of a non-calculator question where we need to find that percentage of a total. Okay, let's move on, and we're going to look at finding a percentage of a quantity using a calculator. So we've just gone ahead and done a non-calculator example. Let's look at a calculator example. We would use a calculator when the percentage was not as easy as doing 5%, 10%, or the number we were finding a percentage of was more challenging. So let's start off with an easy one that we could have done without a calculator. 18% of 30. Remember, percentage is out of 100. So I can simply write 18 out of 100 times by 30. We've seen before that of we can multiply, so that's all I would need to type into the calculator. So 18 over 100, and we would times this by 30. 18 over 100 times by 30 gives us now 5.4. So 18% of 30 is 5.4. On the next one, we've got 23.9% of £45. So we've got 23.9 of 100. I personally wouldn't write a fraction like this in my answer, but as we're just doing a calculation, it would be perfectly fine. So what we can do now is type this in. So we've got 23.9% of 45. So multiply by 45, and that's going to give us 10.755, or 10.8 to 1 decimal place. If we look at the next one, 0.47% of 12. So 0.47 of 100 multiplied by 12, and we can simply put that through the calculator. So 0.47% per 100 times by 12, and that's going to give us now 0.0564. I'll quickly type in the next one, 91.64. So we get 91.64%, and we're going to find that now of £23.76. Clearly, using the last method without a calculator is going to be a real struggle. So that gives us now 21.77 blah, etc. blah. So that's £21.77 to the nearest penny. Okay, if we look at these are just typical examples that we might want to use a calculator for. All we need to do is type it in. Of means multiply, so we would either have a fraction, a decimal, or a percentage. So, for example, just here, 0.34 of 210, that's 34%, or you could just type it into the calculator, 0.34 times by 210, and that will give us the answer. So that gives us now 71.4. So let's look at some typical exam style questions. Jenny took a maths test. The test was out of 78. To get an A grade, she needed to score 84%. What is the minimum number of questions she could have got right in order to get an A grade? So what we want to do here is simply find 84% of 78. So 84% of 78. That's what we're going to do, and then we will round our answer if we need to. So 84% of 78. So if we look at that, that gives us now 65.52. So this is 65.52. And I'm going to write therefore, and just use these three dots, which you don't have to do, 66 marks. So that would ensure that she got an A. 65 wouldn't be enough because that would be less than 84%. So 84% of 78 is 65.52, so we need 66 full marks to get a grade A. Let's look at question number 11. Fred has a tank of water that is 9% full. The tank currently has 45 litres of water in. We're asked what is the capacity of the tank. There are a few different ways that you could do this. What we're not being asked to do here is find 9% of 45. What we know is that 9% is equal to 45 litres. What we could do here is find 1%. If I divide 45 by 9, that's going to give me 5. So if 9% is equal to 45, then 1% must be equal to 5. That means that 100% is simply going to be 500, as we're multiplying both of these by 100. So all I've done here is simply said if 9% is equal to 45, 1% must be 5. Therefore, 100% must be 500. What we could have done is simply taken now 45 and divided it by, and we can put a fraction like this, 9%, and that will give us the total amount. Later on, when we look to set up and solve equations, what we could say is that the capacity times by 9% was equal to 45. So the capacity must be equal to 45 divided by 9%. So this is a little equation, and we'll look at these when we look at reverse percentages. Or if you like, 9% of the capacity is 45. So the capacity, just doing the opposite or inverse, is 45 divided by 9%. Either way round, as you can see from the calculator, we would end up with 500. Okay, we're now going to look at percentage increase and decrease. I'm going to split this up into basic examples and then using multipliers. With basic examples, what we would do is find that percentage of the quantity and then take it away. So let's do a straightforward example. What we're going to do is increase £25 by 10%. So all we would do here is simply find 10%. 10% of £25 is simply going to be equal to £2.50. So if we wanted to increase now the £25 by 10%, all we would do is for 25% plus the £2.50, and that would give me a total of £27.50. If I was decreasing £25 by 10%, I'd find the 10% and take it off. So if I decrease £25 by 10%, I take my original £25, I subtract the 10%, which is £2.50, and that gives me £22.50. So this is a typical non-calculator question. We're asked to decrease £33 by 12%. So if we look at this, we can say that 10% is going to be equal to £3.30. That's 10%. I've just divided this now by 10. 1% is going to be equal to 33p or £0.33. I'm just dividing £3.30 by 10 to get 33p. So if we want to decrease this by 12%, what we can do is find 12%. 12% is going to be equal to 10% plus 2 lots of 1%. So what we'll have is £3.30. We will have now the 33p, or £0.33, and another £0.33. So what we've got here now in total, and if I just add that up, that's going to give me 6, that's going to give me 9, and that's going to give me 3. So if I wanted to decrease £33 by 12%, this is 12%, we can say now that £33 minus £3.96 is going to give me a total now of £29.04. So nice and straightforward by finding 12%. If we wanted to increase £33 by 12%, we would simply add the £3.96 on to get £36.96. So that's without a calculator. What we're now going to do is look at using multipliers. Multipliers are a big part of this GCSE course. So what we're going to look at now is a table of values. We know that 100% of a value is going to give us everything. What we'll do is look at increases and decreases and the multipliers we would use. So if we multiply something by 1 or 1.00, this gives us the original value. So original value. If we look at that in a calculator, let's say I've got £500 and I times it by 1 or 1.00, that is just going to give me 500. What we're now going to do is look at the multiplier 0.99. If I multiply a number by 0.99, this is either going to, we could write it one or two different ways. It will be 99% of the original, or we can see this now as a 1% decrease. So 1% decrease or 99% of the original. So let's just look at this. 0.99 is the same as 99 over 100. So as a fraction, it's 99 over 100. As a decimal, it's 0.99. So if I multiply 500 by 0.99, what we're going to have here is 99% of the original, or a 1% decrease. Of course, this is going to give us 495. Hopefully now you know that 1% of 500 is 5. 10% is 50, 1% is 5. Let's now look the other way and consider multiplying this by 1.01. 1.01 will increase it by 1% or be 101% of the original. So if we look at our multipliers, 1.01 will be now an increase of 1% on the original. So 1% increase in its value. If we look at 1.02, this would be a 2% increase. 1.05, a 5% increase. 1.1 or 1.0 will be a 10% increase. 0.95 would be 95% of original or a 5% decrease. 0.9 or 0.90 would be a 10% decrease or 90% of original. I think rarely do we look at these, and this is why I'm not putting here that this is 101% of the original. It's less likely that we would use this terminology. This is 102% of the original value, 105% of the original value, Whereas this, we might say this is 90% of the original value, sorry, 95 and 90% of the original value. If we had, for example, 0.45, this now would decrease it by 55% or be 45% of the original value, or we could say a decrease of 55%. So let's look at a typical question. What we're going to do is increase, let's increase £136.55 by 12%. So all I would do is simply do 136.55 multiplied by the multiplier we need. A common error here is that students put 0.12. That would find 12%. What we want to do is increase it by 12%. So I'm going to multiply it by 1.12. If you want to think about this now as 112 over 100, that is 112% of the original, or increasing it by 12%. So let's look about 136, what did we have? 136.55, and we multiply this by the multiplier 1.12, and that's going to give us 152.936, so £152.94 correct to the nearest penny. If I wanted to decrease that amount by 12%, my multiplier would be 0.88, because we've got 88% of the original, and we would find that. So if I decreased it by 12%, we get £120.16 to the nearest penny. So if we look at some of these here, what we've got is a table. So we need to fill this table out. So decrease by 72%. If we wanted to decrease something by 72%, we could say that it was 28% of its original value, or 0.28. Increase by 9%, 1.09. This is an increase of 37%. This is a decrease of 29%, or we could say it's 71% of its original value. 15% off in a sale, well, that's going to be 85% of its original. A salary rose by 31%, 1.31. This is an increase of 1%, or 101% of its original. 68% of its original value, so that's 0.68. So all we're doing is simply writing these out as multipliers. If we look at the next one, a reduction of 21.5%. If there's a reduction of 21.5%, it's 78.5% of its original. So we'd have 0.785. That's a slightly harder one. But that's what we'd end up with. A rise of 22.4%. So this would be 1.224. And that's our multiplier. Again, typical question here. Write down the multiplier used for increasing a quantity by 8%, 1.08, and decreasing a quantity by 14%, 0.86. Another typical question. Peter uses the multiplier 0.47. What will multiplying a number by 0.47 do to the number? It will either give you 40% of that quantity or reduce the quantity by 53%. So I would suggest that the answer would be reduce a quantity by 53%. So that is using multipliers now, and as stated, this is quite big in this particular specification of the GCSE. Let's now look at writing one number as a percentage of another. I think the easiest way to look at this is as test scores. So, for example, if I scored 6 out of 10 in a test, we might want to write this now as a percentage. Without a calculator, we can just go ahead and scale this up. So we could write now that 6 over 10 is 60 over 100, which of course is 60%. percent. So writing one quantity as a percentage of another. So I'm writing 6 as a percentage of 10. If we scored, for example, 13 out of 25, we want to know now what 13 is as a percentage of 25. Again, scaling up, timesing by 4 and multiplying by 4, multiplying by 4, this gives us 52%. Of course, calculator examples will come in. So if we wanted to write, for example, 17 as a percentage of 39, all we would do in a calculator is simply get a fraction. So 17 of 39, and all we would do to turn it into a percentage is multiply it by 100. So we get 43.589 or 43.6%. So 17 is 43.6% of 39. You don't even have to times by 100 if you can understand the decimal equivalent. The decimal equivalent 0.439, so 43.589 or 43.6% to one decimal place. So, non-calculator question. In a test, Fred scores 23 out of 25. What was his score as a percentage? So 23 out of 25, I'm just going to multiply by 4 and multiply by 4. That's going to give me in total 92 out of 100, which is 92%. In question number 18, John scored 84 out of 115 in a test. Frank scored 137 out of 173 in a test. Who had the higher proportion of questions correct? There is a section on proportion in this GCSE, and we'll look at that more in depth. But when we're considering which it has the higher proportion, we can either look at them as fractions, decimals, or percentages. So if we look at John, John has 84 out of 115. Frank has 137 out of 173. A common error here is that students say Frank has a higher proportion because he has a higher score. If this was out of 1,000,000 and he only got 137, clearly John has got more questions correct relative to the total number. All we're going to do here, because it's not easy to compare these fractions, is put them through a calculator. So if we start off by looking at John, we will have 84 over 115. So 84 over 115 as a decimal gives 0.73. As a percentage, it's going to give us now 73.0, and I'm just going to write this in, 73.04 ... percentage. Do be careful because often these are quite close in terms of the value. So just having these in, just make sure, because the other one might be 73.06%. Of course, if you want to store this, you can store this as Shift Store A, and we can come back to that by pressing Recall A. So it's in there as 73%. Let's now look at Frank's score, 137 over 173, and that gives us now, and we'll multiply that by 100 to turn it into a percentage. That's going to give us 79.19. So 79.19 ... percent. So we need to answer the question who. The answer is Frank, and we can say by about 6%. You can of course subtract them, and I'll show you how to do that. So all I need to do here is press minus, and this was the answer we had. So that gives us by 6.14% or 147. So you could say by 6.15% correct at 2 decimal places. That's perfectly fine, as I've shown the calculations, clearly comparing them. So that's a nice question on proportion. Make sure you set it out, you compare them, and then you give a final answer. Okay, what we're going to do is look at percentage change, or if you like, percentage increase and decrease. So what we're going to do is look, if a quantity is changed, by what percentage has it changed? So let's start off here. Fred buys a boat for £400 and sells it for £700. It says find the percentage profit he made on the boat. The first thing we do is look at the difference between what he bought it for and what he sold it for. 700 minus 400 is 300. So we look at 300 as a percentage of 400. So if you can see that this is going to be 3/4 or 75%, that's fine. If not, we simply multiply by 100 in a calculator to get 75%. So the percentage profit he's made is 75% of the original, because he's made £300 and 300 as a percentage of 400 is 75. I personally would have just cancelled these off. 3/4 we know is 75%, but again, if you're unsure, you can simply multiply your answer by 100. So let's look at the next one. The value of the painting decreases from £200 to £160. Find the percentage reduction in its value. So if we look, it's decreased by £40. There's a difference of 40. So all we're looking at is 40 as a percentage of 200. Again, you can probably spot this one. 40 over 20, we could write now as 4, you could simplify it down to 1/5. So this gives us 20%. So the reduction is 20% of its original value, or we could say it's worth 80% of its original value. So it's decreased by 20%, and that's what we've been asked to do. But sometimes we'll be asked how much of its original value is it worth? And the answer is 80%. I suppose an easier way to do that is to look at 160 of 200, which is going to give us now 80%. But we're looking at it as a reduction. Let's look at another exam style question. This is question 5 in part A. It says John gets the train to work each week. His fare is set to increase by 12% next year. The fare is currently £140 a week. Find out the cost the fare will be each week next year. So this is just increasing by 12%. So all I'm going to do in the calculator is 140 multiplied by 1.12. This is going to give me now an increase of 12%. We know that's the multiplier. So let's go ahead and do that. 140 times by 1.12, and that's going to give us now £156.80. So 156.80. A common error here is that students put £156.08 or £156.8. Do make sure you're giving it in pounds and pence. In part B, it says in 2 years, the price is expected to be £180 a week. Find the percentage increase on the original fare of £140. So the difference is going to be 40. So we're looking at 40 as a percentage of 140. If you're confident to do that in your head, you can do. Alternatively, you can simply type in 40 over 140 and multiply your answer by 100. That's going to give now 28.57%. So we can say now that this is going to be 28.6%, and that's correct to 1 decimal place. In part C, it says John earns £1,000 a week. Find the percentage of his current salary that he spends on his train fare each week. So he has now £140 of 1,000. Again, if you're comfortable, you can simply cancel this off, which gives 14 over 100, which is 14%. So he spends 14% of his salary on his train fare. So that question looks at a few different skills involving percentages. We're now going to look at reverse percentage. Reverse percentage can be quite a tricky topic. There are a few different ways to do it. The way I like to do it is to write out an equation with a multiply. So let's have a look at this first question. Bill has a wage increase of 10%. He now earns £359.70 a week. What did he earn before? A common error here is that students find 10% of £359.70 and take it off. That's not what we're doing. What we're going to do here is just write out an equation. His wages, which I'm going to call W, were increased by 10%. So they were multiplied by 110% or 1.10. That would be the multiplier we use to increase something by 10%. And this gave £359. So 359, in fact, let's just get rid of that. 359, just write it out. 359.70. So if wages multiplied by 1.10 gave us the 359.70, then the wages are simply 359.70 divided by the 1.10. So we can do this on a calculator, and let's go ahead and do that. So we got 359.70 or 0.7 divided by 1.1 or 1.10, and that gives us £327. So 327, so therefore we can say it was £327. If you want to check that, simply increase this by 10% or find 10% and add it on. What we certainly weren't doing is finding 10% of the £359.70 and taking that off. Question number 2. Kelly buys a jumper in a sale. After a 15% reduction, the price is £48.45. What was it before the sale? So all I'm going to do is put the jumper was multiplied by. If there's a reduction of 15%, then it was 85% of its original value, or as a decimal, 0.85. This gave us 48.45. So to find the value of a jumper, we're simply going to divide. So the jumper is equal to 48.45 divided by 0.85. In a calculator, we can go ahead and do that. So 48.45 divided by 0.85, and that gives us £57. So the original cost of a jumper was £57. Therefore, £57. So that's all we need to do. If we look at this one, the population of an island increased by 16%, 1.16. The mass of a rock is reduced by 22%, the multiplier would be 0.78. VAT is charged at 20%, this would be 1.2, and so on and so forth. So we're just looking at them as multipliers. You could either write them as decimals or as fractions over 100. As stated, there are different ways to do that. One way that you might want to do it without a calculator is the following. So what we've got here, if this is 110%, what we could say is 110% is going to be equal to 359.70. If we divided this by 11, we would get 10%. So if I divided it by 11, going ahead and dividing that by 11, we could find 10% and then multiply by 10. I think that's significantly harder, and if you did get a question like that in an exam, it would be significantly easier. But with reverse percentage, we're working out the price or the amount before a multiplier was applied. Okay, let's now look at growth and decay and simple and compound interest. We'll start with simple and compound interest. With simple interest, you're simply paid on the money that you put in the bank. So you're given interest. With compound interest, you get interest on your initial saving, but also interest on the interest that you've built up. Let's have a look at this in action. So Fred and Frida are each given £400 by their parents. Fred invests £400 in a savings account offering 4% compound interest for 5 years. Frida invests her £400 in a savings account paying 4% simple interest for 5 years. Find the difference in the value of their savings after 5 years. So let's start with Frida and the simple interest. With simple interest, we simply calculate, in this particular case, 4% of 400. So if we do 4% of 400, 4% of 400, well, 1% is 4, so 4% is going to give us 16. What happens then is the interest that we're paid on our £400 is £16 each year. So all we would do here is just have 16 added each year. So we'd have 5 times by £16. 5 times by £16 is going to give us £80. So the total is going to be on here 400 plus the 80, which would give me £480, and that would be after 5 years. So this interest is only paid on the £400 that is put in. If we now look at Fred, Fred has compound interest. So writing this out, Fred is going to be here. What happens with his is he takes the £400 and at the end of year 1 he will multiply that by 1.1 or 1.10. Let's put this in 1.04. My apologies, it's a 4% rather than a 10%. So he's got 4% interest, so it's going to be 1.04, and that will give him a value. What will happen at the end of the second year is that total value will be multiplied by 1.04. So that will be multiplied by 1.04. At the end of the next year, that too will be multiplied by 1.04. Then after the next one, it will be 1.04 and again 1.04. What we have here is 400 multiplied by 1.04 to the power of 5. So all we need to do with compound interest is take the original amount, multiply it by our multiplier, raised to the power of the number of years that we had. This is going to give us more. And what I'll do, I'll build it up and show you how it's going to work. So if we, at the end of the first year, he's going to have 1.04. That gives him 416, as did Frida's. But at the end of the second year, he will multiply all of that by 1.04, and that gives 43264. Now at this stage, of course, Frida would have just had 432. At the end of the third year, we would multiply all of that by 1.04 again, and he would be up to £449.95, whereas she would be at 448. So as you can see, this keeps going. Clearly we wouldn't do this. We would simply take the 400 multiplied by 1.04, that's the percentage, it's a 4% increase, and raise it to the power of 5. So this gives £486.66, £486.66 to the nearest penny. So who's going to have more? It's Fred by about £6.66. Clearly, if we've got compound versus simple interest with exactly the same rate and the same time, it's better to go for compound interest, because this is paying interest on the interest that you're building up, whereas this just works out the start and then just does 5 or however many multipliers of this. So let's look at some compound interest questions. So let's say we invested £350 at, let's go for 3%, and we did it for 6 years, and we wanted to know how much was in there afterwards. All we would do is take 350, we would multiply it by 1.03 to the power of 6. So that's my initial investment, that's my multiplier, and that's the number of years, and we would have £417.92 to the nearest penny. if we had, for example, £600 and we had an interest rate of 13%, and we have this for 7 years, this is going to give us a nice sum, that would give us £1,411.56. So currently, if you could get 13% on a savings account compounded, take it, because as you can see, after 7 years without doing anything, your money will go way over double. So that's what we have. If we were doing this with simple interest now, what we would do is find 3%. So on here, let's have a look. 1% is going to be £3.50. So 3% is going to be equal to £10.50. So all we would do is 6 times by the £10.50, and that's going to give us £69? £63. So £63. So you'd have a total of 413. So the total, if it was simple interest, would be 413. Whereas when we looked at it with compound, this particular example, 350 times by 1.03 to the power of 6, that gave us now 417.92. So we can see that it's always better if you've got the same interest rate and the same number of years to go for the compound. Okay, let's now move this on to growth and decay. Growth and decay often comes with science or with the value of assets. So let's look at this one. Bob buys a new car for £20,000, or a car for £20,000 new. It depreciates, that means goes down, appreciates, increases, depreciates, goes down by 10% a year for 3 years. How much is it worth after 3 years? The killer error here is that students find 10%, which is 2,000, and take that off 3 times. But what's happening, it's finding 10% of its value at a given time. So all we do is write, this is going to be 20,000, so 20,000, and we're going to have 90% of it. So if it's a 10% reduction, 0.9 is the multiply to the power of 3. What this is actually doing is saying, well, if we do £20,000 and we do 90% of this, this is going to be equal to £18,000. So at the start of year 2, it's £18,000, and we find 90% of that. Now, 10% is 1,800. So this goes down to 16,200. Again, it wouldn't go down to 16,000 because we're finding now 90% of the 18,000, not the 20,000. So we could just do this and type it into a calculator. So it'd be 20,000 times by 0.9 to the power of 3, and that will give us 0.9. Let's times that rather than just put in that. That looks a bit better. £14,580. So £14,580. What it isn't is £14,000, and that's what you would have got if you took 10% of this 3 times. Sometimes in the exam you will have double depreciation, and this is an example of it. So it's depreciating at different rates. So a car depreciates at a rate of 8% for 1 year and then 7% for the next 3 years. The original price of the car was £25,000. Find the value of the car after 4 years. So we start off with 25,000. It depreciates at a rate of 8%. The multiplier for 8% reduction is 0.92. And it does that for 1 year. You certainly don't need that one there, but it might help. Then what we're going to have is a 7% reduction after that. We can do this in one straight go. So what we'd then get is multiplied by 0.93. That's a 7% reduction, and that would be for 3 years. All we would do is simply go ahead and put this in a calculator. You can do it step by step. You can do this one first and then this one, but it will give us exactly the same answer if we go straight at it. So 25,000 times by 0.92 times by 0.93 to the power of 3. And that gives us now 18,400. and 21p. So £18,500 and 21p to the nearest penny. So that is an example of where you would have to do different rates for different years. So as stated, if you wanted to, what you could do is just do 25,000, so 25,000 times by 0.92 to find the 8% reduction, which is 23,000. Then you could do the 23,000 times by 0.93 to the power of 3 and do it in 2 steps. That will give you the same answer either way. So that is decreasing depreciation or decay. If we look at this one, a small island has a population of 300 people. The population increases by 12% a year for 27 years. So all we need to do is find the population after 27 years. So we take 300, we would multiply it by 1.12. That's our multiplier, and it would be after 27 years. So all we do is simply put this in a calculator, 300 times by 1.12 to the power of 27, and that is going to give us 6,397 to the nearest integer. So 6397, and that's now to nearest integer. So to the nearest whole person, nearest integer. So just writing that in. And again, you could give your full value, but that island is increasing rapidly each year. So that's what we get. If something is eroding and mass is eroding, then that would be decreasing in value. So that is now growth and decay and compound and simple interest. Okay, VAT. VAT is a tax that's added on. Whilst making this video, VAT is at 20%. It can change. Recently we've had 17.5%, but at the moment it's 20%. So all this is a 20% increase in the value added to goods and services that we might buy. So question 9, a workman is charged £237 plus VAT for a job he has done. How much will the total cost be including VAT? So all you'd need to do is find 20% and add it on, or simply use our multipliers. So 237 multiplied by 1.2. If we go ahead and do this on a calculator, 237 multiplied by 1.2 or 1.20, this gives us now £280 and 80 pence. So £280 and 80 pence. So that is increasing it by 20%. Of course, you could have found 10% and 10%. 10% is going to be £23.70. So you could find 20% by doubling this. If we go ahead and double this, this is going to give us £47 and what's that going to be? £47. Let's just do that. Let's just check I've got this bit right. Let's see what I've typed in here. That doesn't look. So it's 237, isn't it? That's why that's done wrong. 237. Let's type that in correctly. I was just looking at thinking I'm not going to get the same value. So that's 284. Let's change that over. 200. I know I got the. I was just doing that calculation thinking that's not going to give me the same. Error on my part. 237. That's 284.40. So £284 and 40 pence. And then of course this is £47.40. If you added this onto this, you would get this one right here. Again, I would do it with a multiplier as long, of course, as you get the correct number in, which I didn't do just then. So there we go, 284.40. Question number 7. Fred has his car repaired. The bill comes to £650 and 40 pence, including VAT. Find the cost of a bill excluding VAT. So this is another reverse percentage problem. We're not finding 20% of £650 and 40 pence. We're writing out a little equation. So what we can say is the repairs times by 1.20 come to £650 and 40 pence. So the repairs are going to be £650 and 40 pence, divided, which we could of course write as divided by 1.2 or 1.20. Remember, this has increased the repairs by 20%. So this one's slightly trickier as it's a reverse percentage problem. So 650.4 divided by the 1.2, and that's going to give us £542. So the cost before VAT was £542. Okay, question number 9. Jane has 2 quotes for repair she needs doing. Quote A, £350 including VAT. Quote B, £280 plus VAT. Which of the 2 quotes will work out cheaper? So what we need to do is look at quote B. So A is going to be £350 and that is including VAT. B is going to be £280 and we need to add 20%. So all I'm going to do is multiply that by 1.2. So 280 multiplied by 1.2, that's my multiplier to add the 20%, gives 336. So which of the 2 quotes will work out cheaper? B by £14. So make sure you're answering the question. Do the maths, answer the question. In a later video, we'll look at some problem solving, but that is essential that you're comfortable with actually doing the maths and then answering the question. Okay, let's look at the next section, negative numbers. We're going to start with multiplying and dividing with negative numbers. The rule here is if you're multiplying and dividing with negative numbers, if the signs are the same, the answer is positive. If the signs are different, the answer is negative. So if we have a positive multiplied or divided by another positive, the answer is positive. If we have a negative multiplied by a negative, the answer is positive. The same for division. A positive multiplied by a negative is going to give us a negative, and a negative multiplied by a positive is going to give us a negative. So if these signs are the same, our answer is positive. If they're different, our answer is negative. If we don't have a sign, of course, we just take the number to be positive. So if we look at the first one, we've got negative 2 times by positive 3. The number, the numeric value or the magnitude or the size of the number doesn't change. 2 times 3 is always going to be 6. So negative 2 times by negative 3 is going to give us negative 6. We've got 1 negative and 1 positive, so this is negative 6. 3 times by 4 is 12, so positive 3 multiplied by negative 4 is negative 12. 2 times 1 is 2, we've got a negative and a negative. 2 negatives multiplied give us a positive, and that is 2. 4 divided by 2 is going to give me 2. Positive divided by negative, so my answer is going to be negative. 8 times by 7 is 56, positive and negative, my answer is negative. When we've got brackets, it simply means multiply. Positive 2 multiplied by negative 3 is negative 6. 2 negatives divided, positive 5. Negative 8, positive 35, negative 39, negative 4, negative 32, negative 57, positive 50, negative 55, and so on and so forth. So here looks like we've already got this one done. Let's just do this. I suppose it's already done, but we can go ahead and look at it anyway. It says without using a calculator, fill out the blank. So what would we need to multiply negative 7 by to get 21? Well, we could do this 2 different ways. We could do it using a bit of algebra, or we could use logic. I know that the answer would have to be positive. What would I need to multiply 3 by? Or what would I multiply 7 by to get 21? The answer is 3, so this must be negative 3. So I think the fact that that's already filled out didn't help us out, but as you can see, that's what we're going to have. Okay, I must have used that one in a lesson at some point. So nice and straightforward, vary your rules, and that goes for multiplication and division. Let's now look at the addition and subtraction of negative numbers. Often using a number line can help. A common misconception here is that having two negatives make a positive. Let's just look at this in a bit more depth. If we add a negative number, it decreases the value. If we subtract a negative number, it increases the value. So, all we do with addition and subtraction involving negative numbers is find a starting point on the number line. So here we've got 7, which would be just here, and we're subtracting 4. 7 minus 4 is straightforward, and this will give us 3. What we've got here is negative 5, and we're subtracting 4. So subtracting will decrease its value. So all we do is start at negative 5 on the number line, and we go down or decrease by 4. That's going to take us to negative 9. Negative 5 plus 3. Negative 5 is where we start on the number line. We're adding 3 to it. That will increase its value. So we start at negative 5 and we increase by 3. This is going to give us negative 2. This is a typical problem question. Negative 3 subtract negative 10. We start at negative 3 on the number line. If we subtract a negative, we increase its value, or if you like, we add the 10. So starting at negative 3, we're increasing this by 10, which will take us to positive 7. 7 subtract negative 1. We start at 7 on the number line and we're subtracting a negative. Subtracting a negative will increase its value by 1, and this will give us 8. We start at negative 19. We're increasing this by 14, so that will take us to negative 5. Negative 3 plus negative 8. If we're adding a negative, it's going to decrease the value. Often we won't have this plus here, we will just have the minus. So if we got rid of this, negative 3 is where we start. We need to decrease this by 8, so that would give us negative 11. Again, if you wanted to use a number line, you could simply count down by decreasing like so. We start at negative 1 on the number line. We're taking away 12, which would give us now negative 13. We're starting at negative 7 on the number line. We're going to increase this quantity by 11, so that's going to give us positive 4. 25 subtract a positive, well that's going to give me 18. 3 subtract 12 will give me negative 9. Rarely will we see this notation, but here we would start at negative 3, we would increase it by 1, which would give us negative 2. We're adding a negative, which decreases its value. We're subtracting 9 from negative 3, which means we would go down to negative 12. Negative 14 add 17 would give us positive 3. Negative 8 add 2 would give us negative 6. 17 subtracting negative 4 increases its value by 4. This would give us 36. This would give us negative 23. So hopefully you can see now, the first number is where you start on the number line and then you simply follow the operations. So let's go ahead and look at some typical exam style questions. So a basic one here, it says without a calculator, find the value of each of these. So what we've got here is negative 3 times by 6. So this is multiplication. We've got two different signs. We've got a negative and a positive. 3 times by 6 is 18. So this is going to be negative 18. Negative 30 divided by negative 6. Well, 30 divided by 6 is 5. And negative divided by negative is a positive. So it's positive 5. Negative 4 subtract negative 6. We start at negative 4 on the number line and we increase by 6, which gives us positive 2. Exactly the same here. Start at negative 3 on the number line and increase by 7. That gives us 4. Negative 4 divided by 2, well 4 divided by 2 is 2, the signs are different, so that's negative 2. 4 times by 6 is 24, 1 negative times a positive, negative 24. So that's a typical exam style question. This one here, we're asked to fill out the blanks. Looking at these, I personally would use algebra to solve these. But if you're not at that stage yet, we can work out what they're going to be. So 2 subtract something is going to give us now 6. There's a difference of 4 on the number line, so I'd have to subtract negative 4 to increase it by 4. 3 times something is negative 15. We could just divide negative 15 by 3, or we could think, what would we need to multiply 3 by to get negative 15? And the answer is negative 5. With this one, if we want, we could go ahead and subtract 9 from the other side, or what number would we start on in a number line, add 9 to it and get to negative 3? The answer would be negative 12. If we look at this one, something divided by negative 4 is going to give us 3. If you wanted to reverse that, we could do 3 multiplied by negative 4, which would give us negative 12. Or you could think, which number is divided by negative 4 to get 3? 12 plus something is equal to 4. We could go ahead and subtract 12, or we could just write now that this is going to be plus negative 8. I think I prefer to solve these with algebra in a later video, but for now, hopefully that makes some sense. Okay, let's move on, and we're going to look at BODMAS or BIDMAS, or the order of operations. In maths, we have a standard convention of how we calculate certain values. When we read a number from left to right, the first calculations that we do are the brackets and the powers, or we could have B for brackets and I for indices. After we've looked for these particular things, the next thing we consider is multiplication and division. So we can write division or multiplication. The next thing we look for is addition and subtraction. So if we look at the first one, what we've got here is 2 plus 3 times 4. So if we go down this hierarchy, we haven't got any brackets, we haven't got any powers, we've got multiplication and we've got addition. Multiplication comes before addition, so what we need to do is carry out the multiplication before we do the addition. So what we'll have is 2 plus 3 times by 4. So doing the multiplication first, 3 times by 4 is 12, and we simply swap the 3 times 4 for 12. 2 plus 12 is going to give us 14. If you put that in a calculator, you will get 14. A common error is that students add the 2 and the 3, which gives them 5, multiply it by the 4 to get 20. 20 is not correct. If we look at the next one, 5 times 6 minus 10. So we've got multiplication and subtraction. Multiplication comes before subtraction. So 5 times by 6 minus 10. 5 times 6 first, which gives 30, and then minus 10. 30 minus 10 is going to give us 20. So that is the correct answer. I strongly suggest if these are more challenging, you write them out line by line, inserting the new value in each time. If we look at this one just here, we got 2 brackets 6 plus 4. This is just telling me to do 2 times 6, so I could write it as 2 times 6 plus 4. We can see we've got multiplication and addition. Multiplication comes before addition, so we do 2 times 6 first, which is 12, and then we add the 4. 12 plus 4 is 16, and that now is complete. If we look at this one, we've got addition and division. We'll do the division first, so we have 6 plus 10 divided by 5. Division comes before addition, so 6 plus 10 divided by 5 is 2. 6 plus 2 is going to give us 8. If we look at this one here, we've got 10 times by 8 plus 2 multiplied or times by 3. we've got multiplication, addition, multiplication. We need to do the two multiplications first. 10 times by 8 is 80. 2 times by 3 is 6. 80 plus 6 is 86. If we look at another one, let's look, for example, at, let's do this one. What we've got is 2 plus 1 squared minus 1. So 2 plus 1 all squared minus 1. So what we're going to do is the brackets first, then the power, then do the subtraction. 2 plus 1 is going to give me 3. We have 3 squared minus 1. 3 squared is 3 times 3, which is 9, minus 1, which gives us 8. So all I've done is followed the order of operations. If we look at this one, what we've got is 12 over 3 plus 3, and then we've got plus 2. So we've got brackets, we've got division, and we've got addition. So if we look, we need to do the brackets first, then the division, then the addition. So what we'll have is 12, 3 plus 3 is going to be 6, plus the 2. 12 divided by 6 is going to give me 2, 2 plus 2 is going to be equal to 4. Okay, let's look at a typical exam style question. What we've got here is in task 2, it says insert either the greater than, less than or equal sign between each calculation below to make the statement true. So all we're going to do is work out each of these and then put those in. So if we look at this one, 3 times 8 minus 10, we need to do the multiplication first. So this is going to give me 24. 24 minus 10 is going to give me 14. If we look at this one, we've got addition and multiplication. We do the multiplication first. 3 times 4 is 12, plus the 5 is 17. 17 is greater than 14, so we can put now the greater than sign. Let's just tidy that up a bit, and that's what we have. If we look at the next one, we've got 2 times 5 plus 6. We need to do the multiplication first, so that gives me 10. 10 plus 6 is 16. Here we've got now the brackets to do first. 9 minus 3 is 6. 3 times 6 is 18. 18 plus 2 is 20. So we can say now that 20 is going to be greater than 16. If we look at this one, brackets first. 4 plus 2 is 6. 3 times 6 is going to give me 18. 18 plus 5 is 23. If we look at this one, we've got two multiplications. We do those first before the addition. 3 times 5 is 15. 2 times 4 is 8. 15 plus 8 is 23. So those two values are equal. In an exam, I'd use exactly the same technique here. I'm just running out of space. So the last one here, 21 divided by 3 plus 1. Division first, that gives me 7. 7 plus 1 is 8. Here, brackets. 5 plus 3 is 8. 8 squared is 64. 64 minus 42 gives me 22. So we can say now that 22 is bigger than 8. Okay, let's go ahead and move on and look at some more exam style questions. So if we look now at the next one, it says put one set of brackets in the calculation below to make it true. When we put brackets in, it's telling us to do the calculation first. If we look at this one here, now, if I just type this into a calculator as it is, and we'll do that just here, typing it into a calculator, 3 plus 5 times by 7 plus 1, that is going to give us 39, not 57. So what we need to do is simply go ahead and insert one set of brackets. Often it says 2. In this case, we're just inserting one set of brackets such that it will give us 57. I'm looking at this and thinking to myself now that 57 is quite a large number. I know that 8 times 7 is 56. So if I think now, if I can make 8, 3 plus 5 times by 7, that will give me 56 plus the 1 is going to give me now 57. So in doing this, I've created 8 here because we need to do the brackets first. And by inserting the brackets, instead of doing the multiplication first, we do the brackets first here. And that will give me 8 times by 7 plus 1. So if we check that on a calculator now, we could do the 3 plus the 5, times this by 7 plus the 1, and that gives me the 57. So quite a nice question and often requires a bit of adjustment. Okay, find the missing number that makes the following calculation true. So with this one, we could work it forwards, we could work it backwards, we could even use algebra. So 4 plus a number times by 2 is equal to 10. The first thing I would do to this is simply subtract 4. So something times by 2 must be equal to 10 minus 4, which is 6. 6 divided by 2 gives me 3. So this number here is going to be 3. You could, of course, just try that, knowing that multiplication comes before addition. So once we subtract 4, we would need a number multiplied by 2 that gives 6, and you could see that that's 3. Again, you could try values, but that would be the most logical way of doing it. Here's another typical exam style question. Arrange the number cards below to make the largest possible value. You can only use each number once and each mathematical sign once. You must have a number followed by a sign. 643, for example, is not allowed, but 3 times by 4 plus 6 is. So what we want to do is make the largest number. This requires you to follow the order of operations. A common error here is that students do 4 plus 3 is 7, 7 times by 6 is 42. But if we do 4 plus 3 times by 6, what it will do first is for 3 times 6, which is 18, and add the 4. So what we want to do is find the largest possible number. The best way to do that is simply multiply the two largest values. So if I do 6 times by 4, 6 times by 4 is 24. We're only allowed now a one to use each of these once, and then I'm going to do my addition, and that leaves me with 3. 6 times 4 is 24, plus 3 is 27. That's the largest value we could have. We multiply the two largest number and then add the remaining value. So quite a nice question, but it's often it's done incorrectly. And then students want to put brackets on, and it says that we're only allowed to use these mathematical signs once. Okay, what we're going to do now is look at multiplying decimals. So when we're multiplying decimals, you can obviously do this with a calculator. So with a calculator, if you want 0.2 times by 0.52, and you can go ahead and that's what you get, 0.104. Few different approaches to this. The most logical one without a calculator is to consider the size of a number. So this one is 3 times by 1.2. The way I like to do this is to consider how many digits we have in total in the calculation after the decimal points. So if we look here, what we've got is 1 in total. That's just this number here. I carry out the calculation without the decimal point. So all we do is multiply two integers. We know that 3 times by 12 is 36. Here I see that I've started with 1 digit after the decimal point, therefore I need to end with 1 digit. The numbers will be the same, but instead of 36 we will have 3.6. Another way to think about that, if you've got 3 lots of £1.20, it's £3.60. If we look at the next one, 4 times by 1.2, well again we've got 1 digit in total after the decimal point. I remove the decimal point, multiply the integers. I know that this is going to give me 48, so this is going to give me 4.8. Clearly I won't write that in there, I put it up here somewhere, but we get 4.8. So let's move on and look at these. What we've got is 0.1 multiplied by 0.4. We can see that in total we have 2 digits after the decimal point. So I'm just going to write 2 here. I'll remove the digits and simply multiply the integers. 1 times by 4 is 4. The issue here is that we've only got 1 digit. We need to finish with 2. All we do is simply add another 0 before the 4 and behind the decimal point. So this gives us 0.04. A common error is that students write 0.4. Another way of thinking about this, we're multiplying tenths by tenths. Multiplying tenths by tenths will give us 100ths. So if we look at the next one, 0.5 times by 0.4. Again, we've got 2 in total. If we do here now 5 times by 4, 5 times by 4 is going to give us 20. So all we're going to do is simply go ahead now and write 0.20. We've got to, and we could of course write this as 0.2. We've started with 2, we've ended with 2, so there's no adjustment. If we look at this one, 0.2 multiplied by 0.03. We've got 3 digits in total after the decimal points. 2 times by 3, that's going to give me 6. So here, this is going to give me 0.006. We started with 3, we need to end with 3, so I need 2 additional zeros before that 6 and after the decimal point. If we look at this one here, 1.2 times by 3.1, so 1.2 multiplied by 3.1, we've got 2 in total, so all we would do is simply carry out the calculation 12 times by 31. 12 times by 31 is going to give us 372, so 372, so this one is going to give me 3.72. So that is multiplying with decimals. You might want to think about it more mathematically in terms of the place value, what you would get multiplying hundredths by tenths and so on and so forth, or alternatively, this little trick or algorithm or rule may help you out. What we're now going to do is look at dividing by a decimal. If you don't have a calculator, it's easier to make the number that you're dividing by an integer. If we just look at equivalent fractions, if I have 2 over 3, we could have this as 20 over 30. All I've done is written an equivalent fraction. So if I had, for example, 6 divided by 0.2, we could actually write that this is going to be 60 divided by 2. All I've done is multiplied by 10 here, and I've multiplied by 10 here. So if we do 5 divided by 0.4, we can multiply both of these by 10 and do 50 divided by 4. We're going to get exactly the same answer. We don't need to make any adjustments at the end, and all we need to do is 50 divided by 4. 50 divided by 4 is going to give us 12.5. So 5 divided by 0.4, as we can see in a calculator, is going to give us exactly the same value. So 12.5 is what we get. If we look at 6 divided by 0.03, if I multiply both of these by 10, all we're going to get here is 60 divided by 0.3. So what I needed to have done is multiply both of these by 100. So this would be 600 divided by 3. 600 divided by 3 gives us 200. So 6 divided by 0.03 is going to give us 200. If we look at the next one, what we've got here is 0.04 divided by 0.002. If I multiply this now by 10, that isn't going to be enough. If we just look at that, what that's going to give me is 0.4 divided by 0.0, and on this one we'll have 0.2. If I multiply by 10 again, that still wouldn't be enough because we'd have 4 divided by 0.2. What I needed to do was multiply both of these by 1000, and that would have given me 40 divided by 2, which of course is 20. So 0.04 divided by 0.002 is 20. And we could do exactly the same with these. You're just simply making the number that you're dividing by an integer. Let's move on. What we're now going to look at is standard form. Sometimes you might see this as standard index form or scientific notation. With standard form, we have a number that's between 1 and 9.9 multiplied by a power of 10. The advantage of standard form is that it allows us to write really big or really small numbers in a lot easier form. So if we look, this here is a pretty big number. What I want to do is avoid writing lots of zeros. So we locate a number between 1 and 9.9. So if we look at this, we've got 3 2 and then 3 zeros. So this is 32,000. So the number that I'm going to use is 3.2. I need to multiply this by a power of 10. So I multiply it by 10 to the power of something. If it's a big number, this is going to be a positive value. If it's a small number, it's going to be a negative value. There are two ways of doing this. The most mathematically pleasing way is to consider what you've multiplied 3.2 by to get 32,000. And the answer is 10,000. 10,000 is 10 to the power of 4. So we could write 32,000 as 3.2 times 10 to the power of 4. Alternatively, a less mathematical way of thinking about it is that I located the decimal point here. We moved it once, twice, 3, 4 times, and that's the power that I write. So if we look at the next one, we want to write this in standard form. If I look at this number, this is 5,700,000. So I start with 5.7 and we multiply this now by 10 to the power of. I want to multiply 5.7 by a million. That is 10 to the power of 6. Just think, 10 to the power of 1 is going to be 10. And also we'll have 10 to the power of 0, which will be 1. 10 to the power of 2 is 100. 10 to the power of 3 is going to be 1,000. 10 to the power of 4 is going to be 10,000. 10 to the power of 5 is going to be 100,000. So 100,000. 10 to the power of 6 is going to be a million. So all I'm doing here is multiplying it by either 10, 100, and so on and so forth. So let's look at the next one. We've got 4,560. 4.56 multiplied by 10 to the power of. This is going to be 3 because we want to multiply this by 1,000. Alternatively, we put the decimal point here once, twice, 3 times. The next one here, we've got on here 1.25 million. So this is going to be 1.25 times 10 to the power of 6. Again, if you're uncomfortable with that, you can simply go ahead, locate the decimal point. You've moved it once, twice, 3, 4, 5, 6, 10 to the power of 6. So that is writing a large number in standard form. What we're now going to do is write a small number in standard form. There's no division here, we're just multiplying by negative powers of 10. So let's look at this one just here. What we've got is 0.007. So the number we start with is 7. That number we start with has to be between 1 and 9.9. What we do is multiply this by 10 to the power of a negative number. What we've got here is 7 1,000ths. So I multiply this by 10 to the power of negative 3. If we just looked at this and I continued this backwards, 10 to the power of negative 1 is 1 over 10 to the power of 1. You may learn this in algebra. If not, just take it as a given. 10 to the power of negative 2 is 1 over 10 squared, which is 1 over 100. 10 to the negative 3 is 1 over 10 cubed, which is 1,000, as we can see here. So if we're multiplying by 10 to the negative 3, we're actually multiplying by 1 over 1,000, and that's why we get that. If we look at the next one, this is 3.43 times 10 to the power of negative 2. Again, you could locate the decimal point And all we're doing here is simply moving once, twice to the left. So that's going to be 10 to the negative 2. If we look at the next one, what we've got here is 8.7. So that number is between 1 and 9.9. And we're going to multiply that by 10 to the power of negative 4. So that's going to give me 10 to the power of negative 4. This one exactly the same, 3.45, and that would be 10 to the power of negative 5, 6.78 times 10 to the negative 2. If we look at these ones right here, we're asked to write these as ordinary numbers. So these are in standard form. So if we look at this, what we've got is 1.2 times 10 to the power of 3. So what this is 1.2 times by 1,000, which is going to be 1,200. If you were unsure about that, you could simply put zeros after it and move the decimal point. If you think about this, times it by 10, times it by 100, times it by 1,000 would give you 1200.00, which gives that. I don't like to do it that way, but it is there for you. If we look at this one right here, we've got 3.4 times 10 to the power of 5. 10 to the power of 5 is 100,000. So what we're going to end up with is 340,000. So that's writing it as an ordinary number. This one would simply be 6,700,000. Here we've got 1.5, so 1.5 times by 10 to the power of negative 6. So what this is 1.5 times by 1 over 1 million. So if you're happy to write that out, you can do. Let's go ahead and write that. Let's just tidy that up rather than put those in the wrong place. There we go. So let's put 6 zeros on there. So that's our 6 zeros. If you're uncomfortable with this, you can simply load up the zeros in this way and move back our 6 places. So if we do that, we've got once, twice, 3, 4, 5 and 6. So we can see this is 0.000, 0, and then we're going to have 0, 1 and 5. So that gives us now 1.5 times 10 to the power of negative 6. And we can see that that gives us 15 1/millionths. So that's what we get. Sometimes you will see in exams, for example, 12.3 times by 10 to the power of 4. That is not in standard form, and you might be asked to put it in standard form. Remember, this needs to be a number between 1 and 9.9. So this isn't in standard form. We would have 1.23. What I've done is divided this by 10, so we need to increase the power by 1 to get this to 10 to the power of 5, and I need to increase it by another multiple of 10. So 12.3 times 10 to the power 4 is 1.23 times 10 to the power 5. In the same way, if we've got 0.47 times by 10 to the power of 3, for example, this is not in standard form, as that number isn't between 1 and 9.9. So what we'd have is 4.7 times by 10 to the power of 2. We would lose a power as we're increasing this quantity by a multiple of 10, so we would decrease this by a multiple of 10. So that is working with basic standard form. Okay, let's now look at some calculations with standard form. What we'll do is look at some non-calculator and calculator examples. With standard form on a calculator, whilst we're here, we've got a button down here. Of course, you can use simple powers of 10. So if you wanted to type in 1.2 times 10 to the power of 5, we could do that. Alternatively, what we could do is put 1.2 and then put this button and a 5. That gives us exactly the same. So let's look at some examples of calculations with standard form without a calculator. When we're multiplying with standard form, what we do is multiply the two numbers, multiply that by a power of 10, and then add the powers on the 10s that we've got. So 3 times by 2 is 6, times by 10 to the power of 6 plus 2, which is 8. 3 multiplied by 3 gives us 9, multiplied by 10 to the power of 5 times 10 to the power of negative 3. 5 plus negative 3 gives me 2. So we get 9 times 10 to the power of 2. 7 times 10 to the power of 3 times by 2 times 10 to the power of 2. 7 times by 2 is going to give us 14. We add the powers, which is going to give us 10 to the power of 5. This is not in standard form, as our number isn't between 1 and 9.9. So we would write this now as 1.4 times by 10 to the power of 6. I've divided this by 10, so I need to increase this power by 1. If we look at the next one, we've got 3 times by 4, which is 12. We've got now times by 10 to the power of 6 minus 1, which is 5. So this again is going to be 1.2. So 1.2 times 10 to the power of 6. Here we're going to have now 5 times by 4, which is 20, times by 10 to the power of negative 6 plus negative 2, which is 8. So we get negative 8 as our power. We need this between 1 and 9.9. So what we can have is 2 times 10 to the power of. We need to increase this by a power of 10. So this is going to be to the power of negative 7. A common error is put in negative 9. When we're dividing with standard form without a calculator, we divide the numbers and subtract the powers. So with multiplying, we multiply and add the powers. With dividing, we divide and subtract the powers. So on this one, what we're going to have now is 6 divided by 2, which is 3, times by 10 to the power of 6 minus 2, which is 4. 8 divided by 4 is 2, times by 10, 5 subtract negative 3 is going to give 8. 10 divided by 2 is 5, times by 10 to the negative 3. Negative 3 subtract 2 is 10 to the negative 5. 3 divided by 6 is 0.5, times by 10 to the power of 6 subtract negative 1, which is 7. What I need to do here is increase this to 5. I've multiplied this now on here by 10. So what I need to do is decrease this one by 1. So we get 5 times 10 to the power of 6. On the next one, we're going to have now 5 times by 2 is 10, times by 10 to the power of negative 6 subtract negative 8, which is positive 2. So this we need to decrease now. So let's go ahead on this one. Sorry, I've got my error. 5, let's rewrite that one. 5 divided by 2 is not 10. I've multiplied them. Let's start again. So 5 divided by 2 is 2.5. My apologies, 2.5, which is fine, times by 10 to the power of positive 2. Okay, to finish off, what we're going to have is some basic calculator work. So with the calculator work, all we do is simply go ahead and substitute this in, and as we can see, it should be straightforward. So 6 times 10 to the power of 5, and then we can multiply this now by 5 times 10 to the power of 2, and then we'll put all of this over 2 times 10 to the power of 4. So that gives us now on here, let's see what we've done on here. Okay, can't see what I've done incorrectly. Right, okay, let's change that. That's what we wanted to do. I put the power, that's what we wanted. So that's going to be 1500. So this is 1500. We want this in standard form, so it's 1.5 times 10 to the power of 3. So 1500 is for calculation, and that's what we ended up with. So these ones are going to be exactly the same. We simply carry out the calculation on this one. What we've got here is 8 times by 10 to the power of 5 divided by, is that, no, that's going to be plus, that's plus. Plus, so these could be anything. 3 times by 10 to the power of 4, and we're going to divide that now by 2 times by 10 to the power of negative 4, and that gives us 41500. So we need to write that in standard. What's that going to be? Let's write this down. 4.15, is it to the power of 9? Let's write this in. 4.15 times, looks like 10 to the power of 9. Hopefully that's right. So exactly the same. All we've got to do is go ahead and do those. So those are calculations in standard form. Before I go, we may be asked to do addition and subtraction in standard form. If so, simply get the same power. So if we had, for example, 4 times 10 to the power of 3 plus, now on here, let's go for 2.1 times 10 to the power of 4, all I would do is simply write one of these as a power of the other. So what I do is write this as 0.4 times by 10 to the power of 4. All I've done is converted this to a 10 to the power of 4, 2.1 times 10 to the power of 4. So I can just go ahead and add these. So all I would get now is 0.4 plus the 2.1, which is going to give me 2.5 times 10 to the power of 4. This might be beyond the scope of the course, but interesting nonetheless. So all I've done is converted the powers. We could have done this now as a power of 3. I would prefer it to do it as powers of 4, as it's easier for me to add the decimals. So there we go. That is standard form with and without a calculator. Okay, so that is, after 4 hours and 20 minutes, the end of the number chapter. That should be all-encompassing. Most, if not all, of the aspects have been covered, and in the problem-solving section, we will look more closely at some more number work.